para las políticas públicas y para asumir compromisos nacionales e internacionales con metas ambiciosas y factibles. Además, para contar con capacidades para enfrentar desafíos globales y locales en mitigación y en adaptación al cambio climático. La exitosa instalación y gestión del Ministerio de Ciencia se ha basado en vincular la institucionalidad con el mundo científico nacional, incluso más allá de nuestras fronteras.
Así, más de 600 investigadores e investigadoras del más alto nivel, con destacadas trayectorias y vinculados a los principales centros de investigación y desarrollo, así como a universidades nacionales, acogieron el llamado y están trabajando colaborativamente. Coordinados por el Comité Científico de Cambio Climático, la labor de estos profesionales marca el inicio de la vinculación entre la ciencia y el sector público en una materia de interés nacional, y aspiramos a que se consolide como un espacio de asesoría permanente. Impulsar la Ley Marco de Cambio Climático y a través de ella afianzar la existencia del Comité Científico es el reconocimiento explícito a la investigación de excelencia que nuestra comunidad nacional ha generado durante décadas, dando paso a una nueva fase, la de utilizar este conocimiento para construir un mejor país. El Comité Científico de Cambio Climático se organiza en 7 mesas de trabajo, 2 transversales, adaptación y mitigación energía, y 5 temáticas, agua, Antártica y criósfera, biodiversidad, océanos y ciudades. Las recomendaciones entregadas por el comité han contribuido a establecer profundas sinergias y comprometer a otros importantes actores del mundo gubernamental.
Es en las 7 mesas de trabajo del Comité Científico que se ha generado el insumo más abundante, práctico y evidente en torno al entendimiento y abordaje del cambio climático en Chile como un fenómeno en desarrollo al que debemos adaptarnos permanentemente. El conocimiento y evidencia que han arrojado estas mesas de trabajo impulsan el establecimiento de medidas concretas de mitigación y adaptación que consideran la interacción de variables de la evolución del planeta, pero fundamentalmente el impacto de nosotros, los seres humanos.
Los coordinadores de las mesas del Comité Científico utilizan metodologías flexibles de participación de la comunidad científica para sistematizar y contextualizar la mejor evidencia disponible a través de grupos de trabajo, talleres, encuestas, consultas y la construcción interactiva de documentos. El resultado de la mesa de trabajo ha ido más allá de la generación, sistematización y contextualización de evidencia. Su labor también se ha traducido en 188 recomendaciones vinculadas a la mesa del comité, para que entes públicos y privados puedan contar con información clave para la toma de decisiones que permitan hacer frente al cambio climático. El trabajo de la comunidad científica muestra la necesidad de avanzar en el combate al cambio climático, especialmente en un escenario donde la pandemia del COVID-19 y sus consecuencias se han convertido en la primera preocupación de la sociedad.
Demostrar la necesidad y pertinencia de la generación de conocimiento local continúa siendo un desafío interno que impacta en lo global, principalmente por el potencial de Chile en cuanto a generación de energía limpia que puede instalar a nuestro país en una posición de liderazgo en el combate al cambio climático. Ahora, para que este desafío se transforme en una realidad, se requiere de una gobernanza robusta y también que se establezcan y profundicen las confianzas entre diversos actores del ámbito científico y gubernamental, poniendo foco en la carbono neutralidad más allá de cualquier interés y protagonismo sectorial o de corto plazo.
La evidencia a nivel global es contundente. El cambio climático es real y ha generado impactos irreversibles en importantes ecosistemas de nuestro territorio. Si como sociedad persistimos en el ritmo actual de emisiones de gases de efecto invernadero, la temperatura media mundial seguirá subiendo, los océanos se tornarán más ácidos y se calentarán aún más, y el deshielo se incrementará. La mayoría de los efectos del cambio climático persistirán durante siglos, incluso si las emisiones se detienen por completo. Comprometernos con la solución es entonces tarea de todos. Tener un planeta habitable supone construir una sociedad más sostenible y equitativa que, de la mano con la institucionalidad, impulsa un compromiso con una economía más verde.
Como nunca antes, hoy contamos con evidencia contundente y conciencia sobre el cambio climático. El momento para tomar acciones con determinación es hoy. Todos debemos ser parte de la solución. Ese es el desafío del Comité Científico de Cambio Climático convocado por el Ministerio de Ciencia, Tecnología, Conocimiento e Innovación.
Good afternoon, everybody, and thank you to be linked to this third day of the second conference on public policies, scientific evidence, climate change in Latin America and the Caribbean. This event has been organized by the Ministry of Science, Technology, Knowledge and Innovation of Chile, together with the Scientific Committee of the Climate Change Fundación MERI and the European Union. We thank also the support from IPCC, the Inter-American Institute for Research of Global Change, IIA, and the International Network for Government Science and Advice, INSA, and ECLAC. My name is Soledad Quiroz, and I welcome you all to this new day of work. Yesterday, we had a very interesting day with discussions and debates that allowed us to know how Latin America and the Caribbean is projecting adaptation to climate change. We have checked the different chapters of the report from the IPCC, and today we will have another day with experiences implemented or under development in terms of observation and monitoring of climate change. These are important tools to combat climate change and be prepared for the consequences that this report is warning us. To start today, we will listen to the welcoming words of Sebastián Vicuña, the coordinator of the adaptation table of the Scientific Committee of Climate Change in Chile. Sebastián, he is an engineer from Catholic University of Chile, Master in Public Policies in PhD and environmental issues from Berkeley University, Associated Professor of the University of the Catholic University, the Director of the Global Change Center. He also was the main author of the fifth report from the IPCC. Please, Sebastián, thank you to be with us. Thank you, Soledad, and welcome you all to this third day of the second conference on scientific evidence and public policies done by the Fundación MERI, IPCC's Ministry of Science, the Scientific Committee, and with the support of Euroclimate. I wanted to thank this opportunity to open this third day, and grateful because I'm very close to the issues that are going to be dealt with today related to something which is so basic for anything based on evidence, that is to say, having data, information, observatories. Particularly, it is critical for the decision-making in terms of climate change to have evidence through a constant observations of the biophysical and social processes associated to this phenomenon. These last days and years, I've lived important experiences in terms of what is going to be dealt with today, reflecting the challenges that are going to be discussed in the panels. First has been associated to IPCC, and I have been in charge of a working group called the TG Data, Task Force Group for Climate Change Force, to create the conditions to have traceability and transparency of information which is used in the preparation of the reports, and make sure as well that the information stemming from this could be used for decision makings. Information that we have been listening to these 2 days from the different presentations from or by Group 1. I have learned things on the concept of FAIR, that the idea is to make sure that all digital information can be found easily, that it can be accessible, it can be interoperable, and it can be reused. All key elements to do science and to make good decisions, as we have learned with this recent pandemic. The second example that I wanted to highlight was a work done in an interinstitutional commission coordinated by the Ministry of Science as part of the commitments in the National Table of Water, with the idea of coming to consensus and proposing the requirements of water requirements in quality and opportunity, which are needed to make decisions both in the private and public sector and to generate knowledge in terms of the water resources in Chile. The results of it made possible the construction of a unified system of information in water resources that are being gathered in the design of a new institutionality for managing these resources that have been proposed by the government of Chile. In the work that many scientists have worked representing public, private sectors and the civil society, and the challenges of this work and the coordination to be done between the private and public sector, that sometimes they overlap. Nevertheless, they coincide in the objectives, particularly in the need of having the best possible information for making decisions. All along this issues on how to make or can build some observatories, what are the different policies in different countries, are the things that we're going to be listening to in the two panels this afternoon, and I wish them the best of all possible results. Thank you. Thank you, Sebastian, for your words. We also have the salute from Evoc
Recording in progress.
From the European Union in Chile. Evoc is an expert in the policies and international management, and he has covered a wide range of things like commerce, transport, regional integration, and climate change. He has been working for 15 years in the commissions of the European Union from Brussels, and several delegations. He has worked in different regions internationally, including Europe, Southeast Asia, Latin America, and the Caribbean. Thank you for being with us, Mr. Santlek. Thank you, Soledad, and good afternoon to everybody. It is it is a pleasure for me to be here in the third day of this second conference on public policies and scientific evidence. A special salute for Mr. Munoz from the Ministry of Science, to the director of the physics center, Mr. Gutierrez, the assessor of innovation from the European Commission, Augusto González, and my gratefulness for Augusto, that although it is quite late in Brussels, it's just a time for supper, but for us it's also a time to eat. It is lunchtime, but with this table, Sebastian Vicuña as well present with us. As you know, this is an activity which is within the framework of the support given by the European Union through Euroclima Plus for the role of Chile as a presidency of COP25. We have gathered work from different areas to see what the climate change situation is in Chile and Latin America. Local governments, circular economy, and indigenous peoples, among others. This effort has included support to the Scientific Committee on Climate Change of Chile, whose fruits we have seen along this meeting, experience that we consider is very relevant to make known to the rest of the nation, to the region, in order to be commented and explained. As our ambassador said the first day, the European Union considers fundamental to consider science and to put it in the center of the decisions making for public policies in order to address the collective challenge of the climate change. This requires the creation, strengthening of things and meetings such as the one we have today, so that we can have better reflections on having accessibility to the scientific data, so that these not only would allow us to have better decisions based on what is available, but also to monitor the advancement of the policies that are taking. This is precisely the focus of these panels, where we are going to share the European Union experience and also others, particularly monitoring and observation of climate change by Mr. Gonzalez, that gives a presentation on Copernicus system from the European Union. And this is a tool of enormous usefulness for different areas for adaptation and mitigation, such as the identifications of exposed areas, planning of infrastructure, which is resilient, monitoring in the different levels of emissions, identification of areas of potential development of clean energies, which is basic for the European Union. It is necessary to comply with the objectives of mitigation from the European Union, that we believe that, or we hope that we can come to 55% reduction in 2030, similar to Chile. So the delegation is designing a strategy of cooperation to strengthen the development of the green economy in Chile. We believe that this can be key in order to support the transfer of energies in Chile, and Copernicus can play a very important role. I wanted to end up by saying that our fight against climate change, we are making good efforts in the European Union, and I reiterate our commitment to work in Chile, Latin America, in order to strengthen this climatic action in all levels. We believe that, and we hope that the results of these conferences would allow to have better dialogue between the European Union and Latin America in order to share scientific data to change this global challenge. Thank you very much for your attention. Thank you, Evo, to be part of this and to be part of the European Union that I have supported so much to this and to what we have done in climate change in Chile. And with these welcoming words, we go directly to the first panel of today, a panel on observation with experiences of the world and the region. First, we are going to listen to Leonardo Muñoz, but I'm going to listen a bit on the panel that we're going to have today. We know that these strategies on mitigation require data and constant monitoring around the world. Knowing the different experiences in the countries of the region and the European Union gives the possibility to unify criterion and to facilitate international standards done. Today, then, we have Leonardo Muñoz from the from the Ministry of Science of Chile and the head of the Science and Government Office. He's a geographer from Universidad de Chile and master from the University College of London. Leonardo has participated and worked as a professor in the School of Geography of University of Chile and the Ministry of Economy, Corfo, and INDAP. Please, Leonardo, with your presentation. Thank you, Soledad, for your invitation. I'm going to take advantage of this opportunity to share my presentation that we have prepared. Well, first of all, I want to give the excuses from by the Ministry of Science. He was to be here, but because this is one of the emblematic initiatives that we are trying to do, linking science and public policies in order to strengthen data, link it to climate change, which is done through these observatories. Unfortunately, the ministry could not be here, but he made me responsible of giving the apologies in order to reinforce as well the mechanisms to link science and public policies. Okay, as I was saying, Chile, we have a tremendous capability of generating efforts of observation. We have generated important experiences associated with the observation of the space through astronomy, and we have generated as well a tremendous capability globally by taking advantage of our natural landscape to have a better capability of observing the space. This poses on us the challenge of strengthening this capability and to widening up to other areas which are quite relevant, particularly to the challenges that are affecting us today. In our case, in our country, they are expressed through the tremendous vulnerability that we have on this advancement of climate change action. Another element that for us has been tremendously important is the participation that we've had from the panel on from IPCC from 1919, where the Ministry of Science was created quickly. We were incorporated, and through our different committees, we could participate both in the process of COP25 and the international processes such as IPCC. And that was a landmark for us as a ministry because it took us to a global conversation on how this evidence is being collected and incorporated for decision making. And we realized that in our continent, Latin America and the Caribbean, and in particular in Chile, we are weak in evidences in relation to climate change. And these, together with this seal that the ministry want to put from science in order to strengthen the capability of observation, this is the beginning of this observatory that tries to see the diversity of climate that we have in the country. In the extreme north, we have a very arid desert, and we come to the southern tip of Chile, which is the southern pole directly. So it is almost 8,000 kilometers long that allow us to see variability of the effect and the impact of global change, particularly making Chile one of a kind of a sensor for the observation of climate change, accounting for the different evolutions in different areas, particularly our mass of glass, the effect on the sea, biodiversity, the drought, so extensive that we've had along these recent years. This is composed by 3 points. First, we have sensors, data, and governance. In terms of sensors, the purpose of the observatory is, on the one hand, to integrate and to strengthen the capability of sensors we have installed in our oceans in our ice, and even in the Antarctic ice cape, so that into the future we could strengthen all the different kind of sensors that we have. The first step done was to rescue the recommendations that we received from COP, sorry, is we initiated in the first stage conversations with public policies in order to gather all this information, link it to the atmosphere, but we're having agreements with the General Directorate of Water, so with the Hydrographic and Oceanographic Service of the Navy, in order to have data from the oceans, the other services in order to have all the coverage of images of national territory in order to do all this analysis on temporal and space analysis that could be so useful. And we also have a very good linkage with the Ministry of the Environment, and we are working on a system for the air monitoring. At the end of the year, we hope to have a minimal viable product from this system, so that we can gather this experience and make it as a pilot that can be then reiterated. Scientifically, we have been concerned in strengthening the scientific capability we have in our country in the last decade. There have been several centers of research related to climate change, and these centers have been the managers of the equipment through our national agency of research and development, and we have strengthened this equipment. And as we go on, we could have this possibility of widening up the capability of sensors that we have all along the country. In terms of the architecture of the system, there are some elements that for us are tremendously important. Basic points for the implementation of the observatory: the notion of having a system built which is decentralized but integrated. Decentralized because we can build on the capabilities that we have in centers of research and public institutions, but through this observation, we can integrate the information that the different players can be contributing with, and the integration has been seen through the agreement and socialization and sharing of the standards of information that would allow us to have this information available in a common platform. As this goes on, next step, we hope that to be generated by the observatory is to give information that would be feeding this observatory from the different players. And lastly, a very important element for us is what has to do with governance, institutionality that would allow us to give a direction and to maintain the thrust in the implementation. And this initial governance has been thought as a political agreement between the main ministries linked to the observation of the main dimensions that we have identified for climate change. So here we have the Foreign Office from Chile, where we have our Chilean Antarctic monitoring system, that we can have the monitoring of this ice, and with the Ministry of the Environment, because through this ministry we have created this initiative on climate change, and they have generated an important capability related to everything that is associated to climate change that can be disseminated and expanded to other institutions. With these three components, we have seen that as we can strengthen this capability of integrating sensors, extending them, widening them up, sharing formats, standard protocols, and through these we can have the possibility of having a platform integrating information of the climate change in Chile, we can dare say that the future from a sustainable perspective, the future with the observation would allow us to make decisions in order to be adapted to climate change, both in the country that we will start with. Thank you very much, Soledad.
Thank you,
Thank you very
Leonardo,
much.
for this exhibition that show us the relevance of this observatory in Chile to follow up the climate change. Now we invite Mr. Augusto González from History and Geography from Universidad Complutense de Madrid. He worked for the European Commission since 1989 in several policies as education, space, and political. He has several parts in the European Commission and now works in the defense of the space industry and human resources. Thank you, Augusto, for being with us. Thank you for the invitation. And I join the welcome of my companion. I say hello to everybody here, the authorities, the people that join us, and I thank the European Commission for this important moment. I will not do a presentation as the one that Leonardo Muñoz did. It was a challenge that I couldn't read. So I will speak. I will speak about Copernicus. I will show you the service on climate change and a little synthesis on the administrative agreement with Chile that established a link very important as what Leonardo Muñoz told us regarding data of importance for everything regarding climate change. Copernicus is the observation program, as you know, is one of the main pillars of the European Union. Copernicus reaches the state of our planet and controls it and looks at the security of the frontiers and the management of emergencies. We believe that in a humble way, that is one of the surveillance system most important of the world and the main provider of information, open information. European Union, 2/3 of its budget that today is 5,800 million euros for this year until 2027, and European Union. It's the other third. We estimate that this investment will generate benefits, socio-economical benefits of about 131 million euros. Yes, currently, there are 7 satellites operative, and there are some others being developed in order to complement or replace the ones that are working. These satellites will be about 12 to 16 until 2027, and some of them will have new instruments that the present ones do not have. Copernicus has 6 services that share data from the space and interplace as products with a lot of value, added value, as indicators, mobilizers, indicators, and so on. These services are the atmosphere, the terrestrial, the sea one, the climate change one, the management of risk, and a sixth one. Copernicus will be able to develop new services, for instance, to follow up greenhouse gases and services for agriculture as well as security. Data policies of Copernicus gives the information in a complete way, free way, and open way. There are no restrictions regarding its use and the reproduction of this information for commercial uses or non-commercial ones. These policies of management of information applies to the information and the data of Copernicus in a global way, so all the data obtained, as well as the information collected by the services that Copernicus has. Copernicus has now a series of open hubs that are open for the information, with more than 3,000 registered users and millions of people that are benefit indirectly. It is based on international cooperation with the Space European Union Agency and several other agencies that participate, basically linked to the European Union. This Copernicus link international is based on the conversations regarding the climate, the development policies, the help, humanitarian help, or catastrophic help. We have several agreements with different countries as well as Chile and with international organizations. In this theme of this event, I think we should stop a bit in the climate change service of Copernicus. This service gives information regarding the past, the present, and the future in Europe and the rest of the world. As we have said, it's one of the 6 services of this Copernicus program. The service gets information regarding the climate from the World Program of the research in the world, and respond by the world system of observation of the climate, and gives a good resource for the world frame of services regarding the climate. This service is executed by the European Center of Meteorological Preventions at a medium run, and it's in the name of the European Commission. The mission of this service is to support the policies of mitigation of European Union, giving coherent and coherent information regarding climate change. It offers free access to the climatic information based on the best knowledge of the scientists that we have. And the service gives access to the different varieties and models regarding climate change. Also, it proposes registers of climatic data that surveys on the climatic information, like the greenhouse gases and the variations in the climate, like the temperature in the surface of the air. Also, regarding climatic events, the state of the climate and the main indicators of climate change. Sectorial information also for agriculture and for fishery, health, energy, water, tourism, or biodiversity. A very important aspect of this service is the gathering of climate change climate data store, which is a window regarding the past, present, and future climate that facilitates the access of a wide range of information, and has tools online that enable the users to apply this information to their needs. This service provides a lot of information regarding the global conditions and regional conditions on climate that can be projected as a service of climate change of Copernicus. The Union and their state members have high quality information to support legislation as well as measurement for climate change and mitigation of it. Its access being free and open can be accessed by any country of the world that may use this service and have access to the quality information for any provider on climate change services from the public as well as private sectors. Administratively, the European Commission signed an agreement with Santiago de Chile in last March with Universidad de Chile. Thanks to this agreement, Chile will have access to all its service in a free way through a special channel that will provide data transmitted directly to this hub. The agreement is based on the principle on reciprocity, thanks to which Chile will provide in situ the information, and Copernico will give it distribution throughout the planet, giving to the agreement a protection at a regional level, because these data form part of the information that Copernicus provides in a free and open way. That is why Leonardo Muñoz's exposition was so important, because this information has to do with not only the financing, because each part provides its cost, but also you have to be registered in order to use this information. This agreement is part of the European Spatial Agency. With this example of collaboration among the European Commission and Chile, I finished my intervention, and I am ready for any question you may have. Thank you, Augusto, for presenting the summary of the importance that has for the monitoring of the climate change, this Copernicus program. And now we receive our third exposition, José Manuel Gutiérrez. He has a degree on mathematical science, has a doctor in sciences from Universidad de Cantabria. He's professor of research in the Superior Council of Spain, director of the Institute of Universidad de Cantabria. His research is centered on the regional analysis of the climate, including climate change projection. He's coordinator of Global and Regional Atlas of Climate Change for the IPCC, and the point of contact among Europe and CORDEX. He is director of IFCA and co-director of the Master of Data Science of Universidad Internacional Menéndez Pelayo and Universidad de Cantabria. Good afternoon, José Manuel. Thank you for being here. Please take the floor. Good afternoon from Spain. I join you with congratulations to all the speakers that took the floor before me. I have a presentation. Here it is, and I hope it is well seen. Could you please confirm? Yes. So the objective of my presentation is to show you from IPCC perspective the importance of the observation and the data of observation. I have coordinated the atlas and the interactive atlas of the sixth report of IPCC that has been presented recently. And the presentation that I will do is very short, but gives a perspective not only of my chapter, but also of the importance of the observation and monitoring on climate change. In particular, those that have seen the presentations of the result of IPCC, maybe you have seen these conclusions of the report, and it talks about the recent changes on the climate that are very wide and fast and have no precedence from thousands of years. In order to arrive to these conclusions, it is clear that the observations are basic. The observations are the ones that allow us to analyze the changes on the climate. That's why in the different chapters of the last report, on the sixth report, there are results on the observations in chapter 2 on global observations in order to monitoring the present warming and which are the trends in the different regions of the world, trends in rainfalls and other variables. In the 11th chapter, we see present observations in the climate, but emphasizing in the extremes event. This is the chapter where we analyze the extreme events from the report. And finally, the atlas is another chapter of the report, and the tool that accompanies it is an interactive atlas that includes information at a regional level, because in the atlas what we have is a synthesis of the main changes and the projections to the future region per region. And so it's important to observe at the regional level and to collect regional information. This is, for instance, one of the clue figures of the report, the one of the executive report, and it quantifies how much we have warmed up to now. There is an arrow here that indicates us the last 10 years, 2020 period, and having global observation from the medium average temperature, we can quantify how much we have increased the temperatures from the base temperature, which is pre-instrumental, pre-tools, pre-industrial, that is from 1850 to 19, more or less. And for the conclusions that we have in the report is that temperature has raised in 1.1 degrees Celsius degrees, and it is needed to have global information of the temperature in the surface throughout the period that you see in the figure, that is from 1850 until our days, more than 1 century. So we have observations, long observations, and we are talking of a long period in which we recover information. The interest is not only the average temperature of the planet, but also the regional changes, and that's why we use the tools that we have. This is an image of the trends in the last 30 years with the different degrees per decade, and gives an information with the data of the 5th data Celsius that we are using in the report. So in order to prepare this information, the institutions that are in front of are supported in source of information that in the case of temperatures are basically in situ information and punctual information. This is a figure that shows us the global net of research that is on hand, and where we can observe that there are regions that are very much populated And there are others where we have some gaps where we don't have information, so it affects the uncertainty of the estimations we can do. So it's critical to have more information and augment the research in the places where we don't have information, basically based in the resolution 40 of the meteorology global office that says that everywhere we should collect information which is essential for climate observation. In the same line as before, we have to access in a free way this information so that everybody can use it. Anyway, what we have is an uncertainty that comes from the observations, because not all the data use the same elements to observe these variables. So there are different techniques, different ways of observing the space of data is different than to go in an homogeneous way. So the figure on your right show us different data in HatCrat in black, or in Berkeley Earth, or some others source of information that show us different data sets that give us an estimation of the global average temperature at a regional level. And this data give us an uncertainty associated to the estimated information that we can have. When you get an average at a regional level, you get different gaps of information. So in the IPCC, we have an estimation of related information with this dispersion, spatial dispersion of observation, considering uncertainties that can be estimated in each of these data sets. There are also information coming from satellites, as was said in the previous exhibition, and these gaps here correspond to the net that measures rainfall, and the spaces you see in white is where we do not have stations to make an estimation of the information. And in the middle information, you can see the GPCP with information of satellite that give a coverage, a spatial coverage, complete. And so that's the future. We have to go integrating all this C2 information, this local information, and work with initiatives as Copernicus. That is a very valuable initiative in this sense, but with other products also that are the nets of analysis that integrate information in the space of a model that gathers all the information, obtaining variables that are not the standard ones, but are like for rainfall and temperature. So if you want to make a study on variables that are more exotic, as it could be variables as wetlands or other elements, the variables are a valuable possibility, but it could give us anyway some uncertainties. But in the IPCC, we integrate all these sorts of information, data sets with many analyses, with several variables, and we estimate all the uncertainty of all these elements. And in each cycle of IPCC, in the present report, the observations are better because we have had better tools for information. But for many other activities, it is basic to monitor and observe and better the tools we have for doing so, filling these gaps that we presently have. This is the the present temperatures for August, the anomalies that we had in August this year, considering the period of the last 30 years. And well, what we saw is that it's based on an analysis of Copernicus, the European Center, and these products are almost in real-time disposal, so it can be for the public all this information. And given the last report of IPCC covers up to 2020. So in the last year, in the last update, we will have this information in a time frame that is less than 1 month. So it's very useful. These problems that we are saying of observation are more relevant and more important when we speak of extremes. These are some of the conclusions of IPCC that is undiscussable, that the human activities are causing climate change in extreme climatic events as different indicators that each time are more frequent and severe. We need to have historical data on local information, but historical regarding extremes and the problems that we have regarding this observation are even greater. This is a figure, the 9th figure of the chapter 11, where we see 3 extreme indices. At the left, for instance, the temperature, the maximum annual temperature, the hottest day of the year, and this data is from HAD Extreme 3. What is observed is that there are many areas in gray. Because of the lack of observation, we cannot give it the information because we don't have observation in the gray areas. Not only are important the data of observation, but also are very important the studies at the regional and local level that enable at a regional level to build a figure as the one you see here, that in different regions of the world, and these hexagons show you the limited areas in the different continents, North and South America, Europe, Africa, Australia. So here what you see is in red, where we have studies based on data that maybe are very local, but they indicate an increasing of the warm extremes. If we go to the same figures, but for rainfall, there are a lot of limited data or literature, because these results are also based on literature that depends on data that are more or less locals. We have some gaps of information regarding this issue in several countries and zones that enables us to give an estimation. So it's a priority to try to cover all these zones, all these gaps, and to have an estimation that would be wider and more homogeneous in order to see how the climate is changing. To finish, and a tool that is interesting of this interactive atlas that includes observations and projections for the future, global as well as regional. This allows to analyze the projections using periods of future and also warming levels. And these observations allow to see periods in the past, but also provides several visual maps, time series, scatter plots, tables with information, with summaries of changes and values for different regions that allows to produce an analysis at a regional as well as global level. And linking this with the chat of Sebastián Vicuña at the beginning in the welcoming chat, all this interactive information is being implemented according to the philosophy of making everything reproducible that can be spread around. So all this information available and some notebooks, some tools that allow us to use all this information. And the information is here with different data sets as HatCrats that we saw previously, the one number 5, the Berkeley Earth, with global data of rainfall, with data of satellite data, also the ER85 that considers trends and analysis with data, local data, and also some other regional ones like DAMET for North America, EOBIS for Europe, Aphrodite for Asia, and some other ones for Australia. These regions have their data sets, regional data sets that are open and that are useful for literature. And we have had all of them in interactive data for climate, regional as well as global, and you can see them and touch them. You can select a region, in this case, Central Europe, and see all the time data, or as well as punctual data if you want. And finally, as I was commenting at the regional level for Europe, for instance, also from Copernicus, we can rescue the information for these comparisons. So in the interactive atlas, what we have done, that those data sets that have been used in the report, in the different chapters, we have put them, included them, so one can visualize them, compare them, and make analysis, basic analysis as the ones of trends, with the information that is available for the maximum users, and we can give a step further in the importance of all this information of global and regional observations. This is everything, and I am attentive to all the questions that may be raised. Thank you. Thank you so much, Mr. Gutierrez. It was very interesting with all the capacities and interactive maps that are in this report to share with all the ones that want to use it. Before opening the panel of discussion, we will invite Diego Rivera, who will be in charge of moderating this panel. And we say to the public that you can send your questions.
Diego, welcome. He is a professor of Universidad del Desarrollo in Chile and the main researcher of water and agriculture from the Center of Research of Water Resources for Agriculture and Mining. His investigation explores how water interacts with the environment, infrastructure, the society, and public policies. Diego has contributed with conceptual and technical tools with a multidisciplinary trajectory, and he participates in fora and working groups as expert of climate change, being part of national committees of high level and advising governmental agencies. Welcome, Diego. Please, you are now in charge of the panel. Thank you, Soledad, and thank you for the ministry to be here. I know the work of each of the panel members, so I'm not going to be a fan of anyone during the questions. I wanted to propose a first question on what would you think that could be the impact both in the adaptation to climate change and democratization of data from the actions and initiatives that you have mentioned. So I would like to hear from you what are these potential impacts. If you like, we can start by Jose Manuel. In the case of the analysis of tendencies and the recent historical records, having homogeneous data at the global level or continental level, or even regional, is critical. Whatever the reason is, if we have this public information available, it's important, and there is a gap, so the data will be less reliable for the country. So there are many data that are generated by interpolating the different research available, and the final user is not aware that there is a gap, particularly because those are just filled up. But when the density of data is very small, or there are a lack of data, this data does not correspond to the general particularities of the region. And this is not easy to consider, because if you are an expert in data analysis, observations, you know all that, that the products that are published and that are available freely, although they can have some information and documented, not always everybody has got time to read this documentation in depth. So for all the recent studies on tendency, is critical to have all existing possible data. And that is the countries are being united to this trend, regardless the quality they have, because obviously it's important to see then what are the data which are valid for us, etc. So we have to go to a policy of open data. The sooner, the better. Thank you. Augusto, how do you see the impact of this the initiative of Copernicus in Latin America in terms of potential adaptation measures and democratization of data? Well, I believe that here we can tell a small anecdote. The European Union has been visionary in these matters, because in one time, I would say early in time, in the discussion that normally we have in these legislative processes, to finally we have a program done and discussions that the member states participate, and this is within the framework of Europe. There was a discussion on the interest and lack of interest, maybe, of making data of Copernicus could be free. Not everybody was convinced that this would be something okay, because Europe was investing in infrastructure that generates data. Why to put this data to the availability of everybody in the world on a free and open way? Important to highlight the point. The European Union was visionary because the conclusion was that that of adopting a free access policy of this data, not only within the territory of Europe, that hubs, etc., can be accessed, but being proactive and to put into practice cooperation mechanisms with the partner countries such as Chile, so that through regional hubs, the access to these data could be facilitated. On the one hand, we have all the centers that allow within the European territories, and obviously we have all the tools given different services, and particularly climate change data. And fantastic, Mr. Gutierrez showed slides from this just to show how usefulness or how useful they are in terms of graphs. So these data then are available, are facilitated within the European territory, but it would be better to have access from other areas through cooperation agreements with partners countries such as Chile, for example. And the important point is this important volume of data is that there is the need as well of having this data and knowing how to use them, knowing the context that they are in. So this could be done fantastically well because of the sensors we have, the monitoring devices, etc. in Copernicus. But we also have the possibility of increasing our data set from countries such as Chile. So the thing that I could highlight here, that this vision, a little bit visionary, the European Union took, was revalidated by the scientific community and based, I would say, on the conclusions that Mr. Gutierrez has presented today, that it is then something that we should continue working with and opening the possibility of having this policy which is open. So this policy from the European Union has been validated by the needs that we have to face today. Thank you. Leonardo, what could you say about that? Thank you, Diego. In our case, as a Ministry of Science, which is quite new, one of the emphasis we've had is how to go into the democratization of data, not only in climate change, but also in other dimensions. One of the first steps that we took was the data from our agency of research and development that we made them available. The recent experience of COVID made us that as a ministry, we created the capability of annexing set of data associated to the pandemic. And they are available now. Those are data that are, I would say, they are gross, without processing, without any treatment, but they are available for the community, for those who take some applications and use this kind of models, etc., and they can deal with them. So as we can build this observatory on climate change, the idea is to reinforce the possibility of accessing data. That is to say, making it democratic in nature. And it has to do hand in hand, it goes hand in hand with the principle that Manuel was presenting, the purpose that we have seen from our experience from this possibility of having a unified system of information. It was Sebastian, the one the person who gave the first salute today, he was part of the advisory committee of research and public information, and he showed the possibility of exploring these principles so that they could be locatable and accessible. Based on this experience, we took it into one of the deep points that we have to address. That is to say, the information that we have and that we can warehouse as well should be open to everybody who would need it and who would create research and results out of it. So this would be something for a better contribution for the design of different initiatives against climate change. There are some areas in the world that are affected very extremely, and obviously they need adaptation and mitigation, obviously. Thank you, Diego. Before going to some questions that we have collected from the audience, I want to talk about an issue and knowing your experiences on an element which is very important in terms of democratization. These FAIR principles are there, and we have to be as close as possible to these principles, and hopefully we can have a checkpoint. But we need infrastructure data, we have sensors, and we need coordination. So I would like to ask you individually, what has been your own experience, and if you can give us some message on good practices in terms of governance of data and governance of the platforms that you have presented. There is an important challenge, particularly in interoperability between different agents, even inside a country, interoperability among different agencies inside different initiatives, or even inside a ministry, there is a lack of operationality. So the question then goes on, what would be your messages in terms of good practices or good approaches in terms of governance to have platforms so advanced, such as Copernicus or the Atlas? Mr. Augustus, could you start, please? Thank you, Diego. I don't know whether I'm the most adequate person to respond to this, because as we are a supranational entity, Copernicus belongs to different countries, is a unique program. Maybe we do not have these problems of fractioning that might exist in the other contexts. Let's say that the main problem we perceive is not only the problem of access or compatibility of data. I am not an expert on this matter. That is to say, it is nothing that that comes to the literature that we manage on Copernicus. But more than accessibility or compatibility, we have a problem on capability. That is to say, the preparation of those who are called to exploit this data. So it is nothing, it is not uniformly tackled in all Europe and around the world. And it is clear that in this war that we are waging against climate change, everybody has to cooperate. So if we're talking about substantiating these policies of adaptation and mitigation in or based on science, we need this science data there so that the researchers can take use of it. So this has to do with capability and competence. So I believe that there is an important question there in which we are to be very open, not only to have access to data, but also to favor the cooperation so that we can train people so that they can use this data and create adaptation and mitigation policies. And I have to add that the European Commission, although my colleague is not here any longer, they do have a proactive policy in order to support the acquisition of competences that can be useful on a global basis for this fight against climate change. Thank you, Augusto. Jose Manuel, what can you tell us about the barriers or coordination or governance? Well, I normally work at the end of the chain, so it is kind of a harmonization analysis that I do, but from my point of view, what I believe is more important is to maintain standards, because if we have observations which are different, which are not uniform in different regions of the planet, we introduce another source of uncertainties. That is to say, it makes data not comparable or used. So I say standards on data or standards of systems of monitoring and the standards for measurements, that is to say, the orders of measures, etc. So everything is important because otherwise there would be a process that the final product will have not the same quality as if you have taken them with a certain standardization. So I understand that this is proposed by the International Agency of Meteorology and Aeronautics. So this could be applied intra-regional at a interregional scale and a national scale, and so that this data could be harmonized as much as possible, so that interoperability could be easier and cleaner, so that the information is not lost. I believe that standards and coordination is the basic point, I would say. Thank you, Jose Manuel. Leonardo? Thank you, Diego. A question on governance, in our case, designed is one of the components that we as a ministry have posed as one of the challenges and one of the building blocks of our ministry. One of the things that we have seen and learned is that if you don't address the institutional political factors, you cannot go to initiatives that would involve more than one minister. Particularly for us, having a governance designed for climate change implies something quite similar, as Jose Manuel was saying, is to look for standards that would allow us to calibrate the sensors for collecting data in the field, but also to fix the standards on storing and managing. That is to say, to make sure that these data are robust and solid, and we can build a better evidence. So we go to the bottom of the chain, and we understand that as we have the best possible data, we can build the best evidence possible available. And this is done through a governance that would share purposes, that would share standards, but also a governance that would give direction to the actions that are contained in this project of a project that conceptually has got a change of a paradigm in terms of how we understand the access and management of data. What we have today in our scenario, which might be similar to other countries in Latin America and the Caribbean, the case of Chile, we have a multiplicity of data and platforms from different dimensions associated to climate change. In the case of water, we have identified 21 public agencies associated to different spaces of generation, storing, distribution, etc. So, for example, the World Bank identifies that in Chile there are 43 institutions linked to water management. Half of them are linked with data. So if we go to a governance to allow this a better coordination between these 20-something institutions and agencies on water, we are just obviously capturing better data. So maybe we have not come to the reach yet to understand it better, but we just started by the 3 ministries which are strongly linked to climate change in the 2 initial dimensions on oceans and ice. Ice in the mountains and ice in the Antarctica. And we have increased our participation there and widened up our governance and perfected our governance. So what I was to say, we have looked for an administrative tool that would allow us to give to give uniformity. That is to say, it's a legal tool saying what are the institutions and what the role of them will be. And I rescue as well what Augusto was saying from the legislative point of view. In the case of water, because of the complexity of the coordination of the water information, one of the landmarks we did was to install a capacity which is discussed in Congress in Chile, that we can have a vice ministry in order to have a division in charge of the water information, to establish standards and minimum processes to collect information and disseminate information. For sure, the observatory, as it goes bigger and bigger, will go towards an initiative of this kind, because as we gather more institutions, we will have a better institutional capability, more robust to coordinate actions and making all actors promoting and contributing to the same purpose. It doesn't mean that everybody has got the same category. Something that we learned is the importance of how do you rule technically this data. That is to say, who is ruling or defining these standards. They have the mandate of making sure that this data will be used this way. And this will allow accounting for the data gathered is a viable and reliable data that aims at our purposes, contributing more knowledge on the one hand, but also contributing with data and information to make better decisions, both in the public sector and in the private sector. We hope that this component of governance is one of the fundamental elements that would allow us to progress firmly, maybe not as quick as we could and we should like, but we are sure that it will be institutionally robust to go on. Thank you, Leonardo. I would like to thank everybody who is watching in the conference. We have received several questions. Many of them has been answered during the presentations. The ones that have to do with the coordination need between the meteorological services at a regional level, but the different services at the national level, academia, and there were some technical questions as well. The effect of uncertainty or lack of signals in some areas that could generate any kind of a bias. Big part of these questions have been answered, and I want to thank all the people that have been quite active in the chats. There is anyway a question which is a little bit concrete, that has to do with the opportunities of training, capacity building inside the countries based on Copernicus experience and the AR6 Atlas. So the audience is asking that if Jose Manuel and Augusto could tell us what are these options for capacity building inside the countries through seminars, short courses. How could we have access to this capability?
Le cedo la palabra a José Manuel.
Gracias, Augusto.
Thank you, Augusto. The training team, I am from the Institute of Mixed Research of the Superior Scientific Institute from Universidad de Cantabria, and the training team is fundamental because it deals with developing products with the training, adequate training of these products. So I understand that for monitoring and observation, the Meteorology Institute has certain programs and technical capacity of all the instrumental part, and it is true because we need to give trainings in order to implement all these tools. I do not know well if what exists, but according to the talks with some colleagues, I see that the users, when try to use products as the ones generated by this IPCC report, there is information with added value, like Copernicus products that help the life of the users with all the information, providing all the information that where they will support their research or launch different tools that have another added value. So it is good to have programs that would allow to diffuse and give spread webinars as the ones we are now today, or documentation or information, printed information, or in any other format, as there are many tools today to make notebooks or formats that have text, and also some codes that are useful for the computer to detect and to use virtually. So in the interactive atlas, for instance, we have developed documentation that has videos, short videos, where you are trained in order to use these interactive tools, a short video that allows to publish different different things in Twitter, and you can use these analysis capacities of historical data in the interactive atlas with a regional analysis or a global analysis in an adequate way. So the idea is to keep on producing formulas of divulgation and diffusion of different webinars, remote seminars that could give diffusion to the different groups of work of IPCC or in the task group on data, as I mentioned at the beginning, that promotes a series of activities of diffusion, tools, data, and the use of these tools and this data that will be announced during the coming months and years, so that all this information can reach in the best way and with good practices for the users. Thank you, Jose Manuel. Thank you. It is very interesting, this experience on how we have gone further in these platforms and giving disponibility to the experience of the users, this thing of friendly platforms that are easy to use and easy to reproduce. It's good that we have gone through all these different difficult processes that we had to pass years ago to reach an indicator or a graphic. And we all did different things. I want to thank all of you, the members of the panel, for this great opportunity. And I think personally that it has been an honor for me to share with the three of you these initiatives that have so great impact in democratization and access to information. I want to answer a very brief question that appeared. It was asked regarding the possibility of integrating data for land information together with satellite information. And in Chile, we are doing so in agricultural field, especially, but there is a lot of technical capacity that in the country that we need to coordinate. Before closing this panel, if you have something to say in 30 seconds, only 30 seconds, regarding the theme of this panel that has to do with the capacity of observation of climate change. Leonardo, please, in 30 seconds. Thank you, Diego. For us to reinforce the observation capacity of climate change and its effects in the national territory is something that allows us to reinforce the chain of data that reinforces also the evidence, the possible evidence that will generate a better knowledge at a scientific level. And from that, we could inform and take the best public policies to face, mitigate, and surpass the climate change. So it has been an initiative, not only local, but the potentiality that we see in order to have standards is a mechanism that allows us a dialogue together with other organizations at an international level or organizations from other countries like Copernicus that allow us to integrate the information and take the interactive map from IPCC and see our scenarios in our own territory. So these are initiatives that motivate and generate in us a lot of enthusiasm to have data and contribute with this information as a ministry, focusing on better public policies. Thank you, Jose Manuel. Please, your last reflections. Well, I don't have nothing else to add. For a policy of a free use of data and reinforce the monitoring task, which is vital. in order to have a clear evidence of where we are going and without so much uncertainty in order to arrive to solid conclusions. Thank you. Augusto, please. Just to emphasize on something that I said, Copernicus data are of free access, and comprehending the question regarding how to reinforce the capacities, the European Union pushes some initiatives like Copernicus, and I invite all the ones interested to visit Copernicus website and to know all the initiatives we have that correspond to the organizations that have this capacity to process and to get the information and transform this information in order to be the motors of this training and this capacity that there where it is needed at a national level or regional level, as the European Union is doing with its policies. Thank you. Thank you to the panelists and to the people that is looking at us. I say bye-bye to everybody. It has been a honor for me and a personal, a very important milestone in my professional career. Thank you. Soledad, for you the floor. Thank you, Diego, and thanks to all our panelists. It's very interesting for us to go forward in the monitoring at a global level and at a international collaboration to face climate change altogether. Now we will have a break until 16:30 Chilean time, and we will continue to see some monitoring experience in Latin America and the Caribbean with the exposition of José Marengo from Brazil, Juan José Nieto from Spain, Ecuador, and Paula Etala from the program of Blue Camp from Argentina. Thank you everybody who has been connected and hearing this exposition. In the break, we will leave you with some videos that show the scientific work that we're doing in the region. Enjoy them and see you back at 16:30 hours. Thank you.
Te presentamos Territoriar, una app que te permitirá aprender sobre nuestra biodiversidad de una manera lúdica, didáctica y completa. Chile es un laboratorio de una invaluable riqueza en biodiversidad presente en sus ecosistemas terrestres y marinos. Descarga la app, disfruta, aprende y educa a distintos cursos y edades a través de realidad aumentada y fichas con información descargable para ser usadas en la sala de clases o desde la casa. ¡Vamos a territoriar!
El cambio climático altera el ciclo del agua. Somos testigos del derretimiento de glaciares y de cómo las condiciones hidrológicas afectan la generación eléctrica, los caudales en la cordillera, el almacenamiento en los embalses y con ello la disponibilidad de agua potable y el suministro para riego. El agua es parte de un todo y no podemos entenderla desvinculada del territorio.
La planificación y gestión hídrica se deben realizar a nivel de cuenca, considerando la interacción entre ecosistemas terrestres y acuáticos. Entendiendo nuestra diversidad geográfica, necesitamos evaluar distintas alternativas de infraestructura, verde, gris o una combinación de ellas, que se haga cargo tanto de la cantidad como de la calidad del agua.
El desierto se expande. Debido a la disminución de las precipitaciones y al incremento de la temperatura, se proyecta que el aumento de la aridez afecte al 10% de la superficie continental chilena, es decir, 71.400 kilómetros cuadrados. Análisis de periodos comparados estiman disminuciones respecto a la media histórica de precipitaciones, como también una reducción en los caudales mínimos diarios y el incremento en los caudales máximos. Esto último porque, entre otros factores, las altas temperaturas favorecen el derretimiento del hielo y de la nieve.
Chile es un país altamente vulnerable al cambio climático y esto tiene importantes consecuencias. Enfrentamos una mega sequía, han sido más de 10 años con bajas precipitaciones que junto a otros factores nos ponen en una condición de evidente escasez hídrica o desbalance entre la cantidad de agua que demandamos versus la que disponemos.
Ya podemos ver cómo la provisión y regulación de flujos de agua son alterados por el cambio climático y otros vaivenes en la demanda, con graves consecuencias para el ecosistema y la sociedad, tal y como la conocemos. La Mesa Agua del Comité Científico de Cambio Climático, convocada por el Ministerio de Ciencia, Tecnología, Conocimiento e Innovación y conformada por 97 académicos, revela la relación entre seguridad hídrica y el bienestar humano como un elemento central para enfrentar el cambio climático en Chile y el mundo, entregando herramientas que consideran factores como la normativa, institucionalidad, información, calidad, planificación y gestión del agua. Cuidar el agua es cuidar la vida. Ministerio de Ciencia, Tecnología, Conocimiento e Innovación.
El cambio climático y la evidencia muestra que la temperatura en Sudamérica superó la del siglo XIX en 0,6 grados Celsius. El cambio climático es una de las principales amenazas globales a la biodiversidad. Altera los procesos fisiológicos de las especies y sus interacciones, el comportamiento de los organismos, la estructura y funcionamiento de los ecosistemas y su distribución. En un ciclo que se retroalimenta, afecta la captura del carbono y la cantidad almacenada en el suelo, los ciclos de nutrientes, la productividad, la polinización y la resistencia a los patógenos, transformando los ecosistemas.
A partir de la generación de evidencia empírica buscamos contribuir a mejorar la relación sociedad-ecosistema para mitigar y poder adaptarnos mejor al cambio climático. Ahora, esto requiere, por un lado, cambiar ciertas prácticas productivas y también prácticas económicas que tienen impactos negativos sobre los ecosistemas y que contribuyen también al cambio climático. Y por otro, reconocer que el ser humano es un componente más de la biodiversidad y depende de él.
El impacto del cambio climático sobre la biodiversidad y la forma en la que nos relacionamos e interactuamos con ella contribuye a que los ecosistemas y las funciones que prestan se degraden, afectando su capacidad de mitigar emisiones y de aumentar el bienestar de las personas.
Las soluciones basadas en la naturaleza son un apoyo importante en las iniciativas de descarbonización de todas las economías en el planeta y en particular de la chilena. Adicionalmente proveen cobeneficios para la adaptación y la biodiversidad y requieren, eso sí, proteger los ecosistemas y restaurar sus capacidades para capturar carbono de la atmósfera.
Cuidar los ecosistemas es imprescindible para evitar el doble impacto en la biodiversidad y el cambio climático. Por ejemplo, cuando el suelo está contaminado, eso se expande a ríos y océanos, promoviendo la proliferación de microalgas nocivas para la salud humana. Asimismo, la pérdida de bosques hace que se deje producir oxígeno y no se pueda secuestrar el CO2 que contribuye al calentamiento global. Impactos como el anterior hacen imprescindible que tomemos conciencia del cuidado de la biodiversidad si queremos hacer frente a los avances y efectos del cambio climático. Atendiendo esta realidad, 105 académicos se comprometieron con el Ministerio de Ciencia, Tecnología, Conocimiento e Innovación, dando vida a la mesa Biodiversidad del Comité Científico de Cambio Climático. Porque potenciar soluciones basadas en la naturaleza promueve el equilibrio entre lo económicamente sustentable y lo medioambientalmente sostenible. Ministerio de Ciencia, Tecnología, Conocimiento e Innovación. Chile es altamente vulnerable al cambio climático. Sus impactos van desde la disminución de recursos hídricos derivada de las fluctuaciones en el nivel de precipitaciones y el derretimiento de nieve y hielo, hasta consecuencias climáticas como la mega sequía que afectan tanto a la población como a la infraestructura y a los sistemas naturales. Al cambio climático se le atribuye la extinción reciente de especies, alteraciones en su distribución geográfica, actividades estacionales, migración de especies, repercusiones negativas en el rendimiento de cultivos, entre otros tantos impactos en diferentes ecosistemas a nivel local y mundial. El concepto de adaptación tiene que ver con prepararnos y resolver las consecuencias de un cambio climático producido, en gran parte, por la acción humana. Es esperable entonces que sea la misma sociedad la que se haga cargo, aumentando la resiliencia y reduciendo las vulnerabilidades.
Para lograr el desarrollo sostenible en Chile, se deben implementar medidas efectivas de adaptación a nivel sectorial, nacional, regional y comunal. Tomando en cuenta la incertidumbre y más allá de la meta a la que aspiramos llegar, la implementación de cualquier medida se debe entender como un proceso en constante evolución que implica resolver permanentemente los impactos que ya existen y prepararnos para los que vendrán en el futuro.
Para avanzar en la adaptación al cambio climático, es necesario hacer frente a desafíos que muchas veces están vinculados con el desarrollo, como son la pobreza, el hambre y la disponibilidad de agua. De las crisis deben emerger las transformaciones como procesos conscientes y guiados que promuevan establecer objetivos comunes, la creación de nuevos modelos de desarrollo y avanzar en justicia social y ambiental. Ello implica capturar y mirar evidencia que nos inspire en el establecimiento de nuevas medidas.
Para responder al cambio climático debemos adaptarnos, y aunque mucho de lo que estamos haciendo hoy es útil, para esa adaptación no es suficiente, por lo que hay que complementarlo con innovaciones y cambios profundos. Debemos realizar procesos y respuestas transformacionales para salir adelante. Por otro lado, aceptar que el cambio climático está lleno de incertidumbres activa el potencial para diseñar procesos transformacionales que involucren a distintos actores sociales, utilizando a su vez información basada en ciencia.
En Chile hemos avanzado en el diseño e implementación de políticas públicas, pero aún existen posibilidades de mejora. Nuestro país debe ajustarse a los impactos del cambio climático de forma transversal, a distintas escalas administrativas y con participación de múltiples actores sociales, donde la ciencia cumple un rol clave al disponibilizar información y evidencia científica al servicio de la generación de políticas públicas y propuestas en materia de adaptación. Es por ello que con la participación de 73 académicos y cumpliendo con el mandato del Ministerio de Ciencia, Tecnología, Conocimiento e Innovación, se construyó la Mesa de Adaptación del Comité Científico de Cambio Climático, generando conocimientos y propuestas concretas de apoyo a la toma de decisión. Porque adaptarse es mucho más anticipación que reacción. Ministerio de Ciencia, Tecnología, Conocimiento e Innovación.
Mitigar es una herramienta fundamental para hacer frente al cambio climático. Es intentar neutralizar la emisión de gases de efecto invernadero, impidiendo que el planeta se caliente en extremo, lo que en concreto se traduce en metas de largo plazo, para evitar el aumento de la temperatura superficial del planeta, más de 1,5 grados Celsius sobre los niveles preindustriales de acuerdo con lo planteado en el Acuerdo de París. Pese a que Chile produce aproximadamente el 0,3% de las emisiones a nivel global, nuestra incidencia cambia al considerar agrupadamente todos los países que se encuentran en similar posición y que juntos aportamos cerca del 40% del total de gases de efecto invernadero. Somos entonces parte del problema, pero podemos ser mucho más protagonistas de la solución.
Debemos tomar posición respecto del gran potencial de Chile en energías renovables, tanto para abastecer nuestros requerimientos energéticos internos como para exportar. Nuestro potencial de producción podría cubrir en torno al 10% de la energía que se demanda en el mundo. Exportar energía limpia permitiría asimismo a otros países dejar de usar energía de fuentes contaminantes, reduciendo tanto las emisiones como sus efectos.
Hay un espacio de eficiencia no explotado, donde la mixtura de energías renovables no convencionales juega un rol preponderante para incorporarlas. Ello implica enfocarse en desafíos, tanto de conocimiento y tecnología, como de capacidades y talento nacional. Ser ambiciosos en términos de intensidad de emisiones de CO2 es un desafío tan coherente como posible, que pasa por descarbonizar el sector energético, reducir la demanda de energía final y cambiar a combustibles bajos en carbono, incluyendo la electricidad. El trabajo de la mesa de mitigación del comité permitió fundamentar los compromisos de Chile en el presupuesto de carbono y la meta de carbono neutralidad para el 2050, conectando la evidencia científica con políticas públicas ambiciosas que responden a nuestros compromisos internacionales.
Debemos hacernos cargo de las interrogantes que afectan el gran proceso de transformación energética que hemos emprendido. Necesitamos planes alternativos que nos hagan menos vulnerables. Esto requiere de políticas creativas y robustas que permitan que un país se organice para encontrar soluciones potentes y se prepare para afrontar un mundo incierto.
Si queremos tener la posibilidad de proyectar un futuro, es imprescindible un abordaje multisectorial y que supere el ámbito nacional. Chile requiere tener y cumplir acuerdos a nivel mundial. Asimismo, la evidencia debe ser la base sobre la cual se adopten las grandes decisiones, con foco en la sustentabilidad, en la resiliencia y la flexibilidad. Con esta convicción, nos comprometemos con el Ministerio de Ciencia, Tecnología, Conocimiento e Innovación y trabajamos colaborativamente con otras instituciones en la Mesa Mitigación y Energía del Comité Científico de Cambio Climático, conformada por cerca de 60 académicos. Colaboración y transversalidad, la épica para neutralizar la emisión de gases de efecto invernadero. Ministerio de Ciencia, Tecnología, Conocimiento e Innovación. La criosfera antártica y la andina poseen los mayores depósitos de agua dulce del planeta, convirtiendo a Chile en la tercera reserva más grande a nivel mundial. Nuestros 24.000 kilómetros cuadrados de glaciares proveen hasta el 50% del agua a nuestros principales ríos durante el verano, mientras que la nieve blanca y el hielo de la criosfera, debido a su capacidad de reflexión de la radiación solar, ayudan a aislar el suelo y el agua, evitando que el calor sea absorbido y acelere el calentamiento global. Pero esto no es garantía de nada, porque la criosfera es altamente vulnerable al cambio climático. La pérdida de masa de hielo en la cordillera de los Andes, por ejemplo, ha sido de 23 gigatoneladas en los últimos 20 años, que equivale a entre un 8 y 10% del total global. También se estima que el derretimiento anual de los campos de hielo norte y sur bordea el 80% de la capacidad total de los embalses de Chile. Los efectos negativos del cambio climático se multiplican, dada la importancia del hielo y de las aguas frías, afectando organismos, ecosistemas y comunidades.
La pérdida de hielo en la Antártica se aceleró en más de 6 veces durante las últimas 4 décadas, mientras que el 87% de los glaciares andinos monitoreados en Chile muestran algún retroceso. Asimismo, el hielo continental perdido más el derretimiento de los glaciares andinos son responsables de cerca del 13% del alza global en el nivel del mar. La criosfera antártica y andina entonces proporcionan muchos servicios al planeta donde destaca la protección, mantención y regulación del clima.
Pero el equilibrio es frágil y es el mismo carbono que emitimos los humanos y que se deposita en la superficie, lo que aumenta la temperatura que derrite la cobertura de hielo. Gran parte de la solución la provee la propia naturaleza, y es la conservación de la biodiversidad lo que ayudará a amortiguar los efectos adversos.
Existen microalgas en el océano que se dividen todos los días, a diferencia de los árboles de sistemas terrestres que requieren de años para su crecimiento. A la fotosíntesis de estas microalgas marinas le debemos el 50% del oxígeno que los humanos necesitamos, es decir, 1 de cada 2 veces que respiramos es gracias a ellas.
En tanto, el krill de la Antártica y los fiordos tienen la capacidad de contribuir en la mitigación con un potencial equivalente a sacar 35 millones de autos de circulación. Sabemos que la sociedad y sobre todo la población más vulnerable sufre los efectos del cambio climático. La ciencia y la academia tienen la responsabilidad de contribuir con información, evidencia y propuestas concretas para los tomadores de decisión. Es por ello que acogimos el llamado del Ministerio de Ciencia, Tecnología, Conocimiento e Innovación, y 72 académicos conformamos la Mesa Criósfera y Antártica del Comité Científico de Cambio Climático, por el bien de las personas y de la naturaleza. Ministerio de Ciencia, Tecnología, Conocimiento e Innovación.
Dependemos de un océano que cubre el 72% del planeta. En Chile, el océano tiene un papel gravitante. 1/4 de la población se distribuye en comunas costeras y 500 caletas sustentan a miles de trabajadores. Gracias al océano, la Tierra es habitable, desempeñando un rol fundamental en el equilibrio del clima y siendo un regulador térmico clave para el mundo. Absorbe más del 90% del calor producido por los gases de efecto invernadero. Almacena más CO2 que la superficie, captura 1000 veces más el calor que la atmósfera y lo redistribuye. Las diferentes amenazas a las que están expuestos los océanos por el cambio climático, como el aumento de temperatura y del nivel del mar, la acidificación del océano o el aumento de las zonas muertas o sin oxígeno, ponen en peligro muchos de los procesos y actividades humanas que dependen de un océano sano. Por ejemplo, nuestra alimentación y la seguridad ante eventos extremos, además de la economía en diferentes aristas.
Pareciera que el océano no acusa recibo de daño. Lo sentimos demasiado grande y poderoso para enfermarse, pero ya es posible observar cómo, en silencio, sufre las consecuencias del cambio climático. Si el océano deja de funcionar bien, se pone en peligro la subsistencia de numerosos ecosistemas y de la humanidad misma.
Chile es un país océano dependiente y nuestro mar muestra signos de cambios asociados a las acciones del ser humano que deberían preocupar a toda la sociedad, pues las respuestas del océano son múltiples, diversas, heterogéneas e impredecibles, y sus efectos son tanto locales como globales.
Necesitamos planes de adaptación en pesca, acuicultura y zona costera, que se unan a marcos regulatorios y legales que protejan al océano. La evidencia muestra que las áreas marinas protegidas han sido buenas medidas para mitigar el cambio climático. Y Chile ha formado un liderazgo internacional en ello. Pero se requiere que dicho proceso participen las comunidades y los pueblos originarios y que se revisen continuamente los progresos. En este sentido, la contribución de la ciencia es vital para obtener la información que permita conocer la evolución y la dinámica del cambio climático.
La observación del estado del océano es vital para aportar desde el conocimiento y la evidencia científica al entendimiento de la vinculación entre el océano y el cambio climático, sus riesgos, consecuencias y posibles asociaciones de adaptación y mitigación respecto de la toma de decisiones y el desarrollo de políticas públicas en esta línea. Es con esta convicción y para cumplir ese rol que 91 académicos conformaron la Mesa Océanos del Comité Científico de Cambio Climático al amparo del Ministerio de Ciencia, Tecnología, Conocimiento e Innovación. el océano es único para todos. Ministerio de Ciencia, Tecnología, Conocimiento e Innovación.
El 90% de los chilenos y chilenas vive hoy en ciudades y ellas son responsables a nivel global del 70% de las emisiones que generan el cambio climático, sufriendo también sus efectos negativos. Es la alta concentración de actividad económica, transporte y densidad poblacional que representan lo que permite enfrentar este desafío como una oportunidad, desarrollando estrategias con gran impacto, tanto en el corto como en el mediano plazo, atendiendo a la emergencia climática desde la planificación y la gestión urbana, en cuanto a riesgos y desastres, diseño y espacio público, transporte, residuos, energía, agua, salud, ecosistemas y biodiversidad, vivienda e informalidad, economía y financiamiento.
Abordar desafíos vinculados a las ciudades y a su impacto implica entenderlas como organismos grandes y complejos, donde convergen múltiples actores. Al dejar que las ciudades evolucionen libremente en función de lo que cada actor dispone, muchas veces las aleja del bien común. Por lo que si queremos que logren objetivos importantes y colectivos, deben contar con una gobernanza clara y potente. Esto es un desafío especialmente importante para ciudades que heredan un esquema de gobernanza tan frágil y tan desarticulado como el nuestro.
Chile es uno de los países más urbanizados del mundo. Sus edificios generan el 30% de las emisiones de gases de efecto invernadero y los sistemas de transporte se acercan al mismo porcentaje. Mitigar y adaptar son caras de una misma moneda. Reducir la vulnerabilidad de las ciudades al cambio climático implica aumentar la resiliencia, lo que redunda en disminuir la desigualdad y segregación. Para que la equidad urbana sea un hecho, nuestro país requiere ciudades más adaptadas a sus entornos y basadas en energías renovables, que permitan reducir la contaminación atmosférica local, contribuyendo de esta forma a mitigar el cambio climático. Tener información y evidencia científica es vital si queremos enfrentar con éxito estos desafíos.
Al enfrentar el cambio climático, no debemos perder de vista otras crisis que se ven íntimamente relacionados y que necesitan de una mirada global, metropolitana, en que las acciones se puedan retroalimentar virtuosamente con un impacto amplio y positivo.
Nuestros actos hoy acompañarán a varias generaciones en el futuro. Es por ello que más de 50 académicos de distintas disciplinas se han reunido en la Mesa de Ciudades del Comité Científico de Cambio Climático, convocada por el Ministerio de Ciencia, Tecnología, Conocimiento e Innovación, poniendo la investigación al servicio de la toma de decisión y el actuar enfático desde las ciudades en el cambio climático. La planificación y gestión urbana son una urgencia para enfrentar con determinación los efectos del cambio climático en nuestras ciudades. Transformemos nuestras ciudades en actores activos para enfrentar el cambio climático. Ministerio de Ciencia, Tecnología, Conocimiento e Innovación.
El agua es la base de la vida. Sin ella, nuestra existencia en este planeta azul sería imposible. Miles de millones se invierten en el mundo cada año buscando agua en otros rincones de la galaxia. Llegó a la Tierra como un regalo del universo. ¿Por qué no protegerla y proteger así nuestra vida?
El sistema hídrico es un sistema complejo y el ciclo del agua es un sistema complejo. Y por lo tanto el agua de la cuenca nace, probablemente puede venir parte de derretimientos glaciares, parte de cuencas altas, parte de humedales altos. El agua va fluyendo, pero el agua va fluyendo superficialmente y parte del agua va fluyendo en forma subterránea. Alimenta acuíferos subterráneos. Es como un sistema circulatorio nuestro dentro del sistema geológico de la Tierra.
La prioridad del agua está súper mal definida en Chile. Una empresa extranjera puede venir y decir vamos a necesitar el 90% del agua de este río y lo pueden hacer. Y no queda para un uso racional o un uso sensato de la naturaleza en que el hombre pueda vivir armónicamente. Son impactos demasiado drásticos, en tiempos demasiado cortos. Entonces eso genera impactos irreversibles.
La ciudad te da una sensación extraña de olvido de dónde vienen las cosas. O sea, los niños, y esto como un cliché, perdona, pero el niño que va al supermercado y cree que el pollo lo están haciendo atrás en una pieza y que la lechuga le hicieron allá atrás en otra pieza, qué sé yo, y no tiene ni idea de dónde vienen esas cosas que se están comiendo. Entonces no entendemos nuestra historia, no entendemos nuestros orígenes, de dónde venimos, y por eso estamos como estamos.
Cuando se produce una crisis tan grande, que no es solo económica, que no es solo ecológica, que es también psicológica y espiritual, que compromete el interior del ser humano. En el otro polo, puesto que todo es bipolar, surge la disidencia. Esa disidencia siempre toma contacto con la cultura popular, siempre. Y con las culturas indígenas. ¿Por qué? Porque ellos conservan todavía esta vinculación con el orden natural. Y ellos saben que no habrá recuperación de la enfermedad mental del hombre moderno si no nos reconciliamos con el orden natural, si no nos reconciliamos con la creación.
Toda nuestra vida, todo nuestro sistema, todos nuestros bosques, todos nuestros animales dependen del agua. Si no hay agua, no existimos como humanidad. Si no hay agua, no existimos como cultura. Nuestros abuelos se guiaban por la señal astronómica, el sol, la luna, las estrellas también. Cuando el sol salía en cierta época del año, ya sabían ellos que esa época comenzaba el tiempo de las cosechas, o el tiempo de sembrar, el tiempo de limpiar los canales. Y eso fue por miles de años que se practicó el respeto al agua. Si no hubiese existido el agua o no hubiese estado el agua en nuestros lugares, no hubiésemos existido como cultura.
Entre los ñen o los seres de nuestra cultura existen algunos que son más importantes, podríamos decir, como el Chahuanti, que es el Padre Sol, la Ñuqueale o Ñuquequillén, que es la Madre Luna, que regula la fertilidad, la siembra, las mareas. Y también el Chauco, el Padre Agua. El agua purifica, el agua revitaliza, el agua nutre, tiene 1000 propiedades y lo más importante es que da la vida. Donde no hay agua, no hay vida. Lo más importante que yo siento ahí es la energía del Chauco, del Padre Agua, y la importancia que tiene respetar su nacimiento y su continuidad en el territorio que llega al mar, y el ciclo natural del agua que debería ser respetado por una política de Estado.
Tú, si alteras este ciclo en una cuenca, si alteras este ciclo a nivel global por deforestación, por falta de evaporación, de humedad, de los árboles, etcétera, etcétera, tú lo que vas a tener es degradación completa del sistema hídrico.
En la evolución de la vida en el planeta siempre se han respetado ciertas leyes. Todos los organismos son respetuosos de ciertas leyes, menos el ser humano.
O sea, él mira la naturaleza y dice, son recursos naturales. La madera es recurso, el agua es recurso, el aire es recurso. ¿Todo para qué? Para hacer cada vez más poderosa tu ciudad, para hacer más poderoso a tus empresarios, para hacer más activa la lógica de los negocios. Para eso, tú llamas a la naturaleza recursos naturales.
El crecimiento económico hoy día se ve como aquella palanca que puede traerle el bienestar a la población. Pero el crecimiento económico además nos está trayendo pasivos ambientales que se van acumulando y que van a terminar poniendo en riesgo al propio ser humano.
Uno tiene que poner antecedentes de que esto no es solamente por salvar a los animalitos, esto tiene que ver con salvar el bienestar de la gente. Entonces, por tanto, yo creo que es necesario el crecimiento, pero el crecimiento infinito no es posible en un planeta que es finito y por tanto la transición ecológica no puede ser hecha con la misma mentalidad que creó los problemas que hoy día queremos enfrentar.
El planeta no tiene los recursos que necesita un desarrollo del 3,5% o el 4% anual mantenido por 50 años. Por lo tanto, la pregunta es, ¿por qué no están haciendo estos cálculos? ¿Por qué están llevando a la humanidad al precipicio?
Entonces el ser humano está literalmente desmoronando a la biosfera. O sea, por un lado, exhalamos cantidades increíbles de dióxido de carbono y después destruimos los bosques y el fitoplancton que podrían absorberlo. Pareciera que estamos en un suicidio, estamos tratando de suicidarnos, desmoronando nuestro propio ser. Este es nuestro propio ser. La biosfera es nuestro propio ser macroscópico y estamos nosotros mismos derrumbando.
El ejemplo principal hoy día en el mundo es el cambio climático. Genera niveles de cambios meteorológicos que son brutales, como lluvias torrenciales, huracanes, tsunamis, etcétera, etcétera, y que va asociada a menos agua, y todos sabemos qué es lo que pasa en una sociedad con menos agua. Sin agua no hay posibilidad de vivir.
Estamos en una situación de estrés de nuestras napas freáticas que es generalizada entre Atacama y Chiloé, donde se extrae más agua de la recarga. ¿Y cuál es la solución que le damos? Es que cada vez que hay una crisis hídrica se profundizan pozos. O sea, agrandamos el problema.
Y por tanto yo creo que la salida de todas las crisis, la crisis socioambiental del país, que también explota la crisis social y el estallido social, y hacia la crisis hídrica, es necesario tener ese diálogo. Porque cuando uno habla de que es necesario ahorrar agua en la casa, me aparecen en Twitter, esto no es sequía, es saqueo. Y la verdad es que es un poquito de saqueo, es un poquito de sequía, y también tiene que ver con las decisiones que nosotros tomamos. Porque tenemos huellas de agua que son importantes, la que ocupamos en la casa, lo que comemos y lo que compramos. Y por tanto la minería no hace productos para robots, son celulares, son computadores, son automóviles. La agricultura no hace comida para otros, son las cosas que nosotros comemos. Cada uno de estos sistemas se puede optimizar y tener menos impactos ambientales, pero tenemos que entender que la única base de esto es que nosotros tenemos que impulsar este cambio hacia una transición ecológica inclusiva, sustentable y resiliente.
llamados es a buscar soluciones de verdad. Y las soluciones de verdad son ajustar la demanda de recursos naturales a la oferta que el planeta tiene de recursos naturales. Si no entendemos eso, nunca habremos entendido el concepto de sustentabilidad.
Debiera ser una razón de humanidad cuidar el agua en todo su ser.
Es la misma gente que tiene que empezar a darse cuenta la importancia que tienen los ríos, la importancia que tiene la naturaleza para su vida diaria. ¿Por qué no vemos más allá? Vemos que dependemos del agua, dependemos de los glaciares, dependemos del mar, dependemos de esta conexión entre las nacientes de un río y la desembocadura. Todos estos sistemas están vivos. Ella nos entrega todo con los brazos abiertos y nosotros no le estamos dando nada a cambio.
Sí, realmente ves lo que estás mirando, ¿no? ¿De dónde viene el aire? ¿De dónde viene el agua? ¿De dónde vienen los alimentos? ¿Qué es lo que te puede dar realmente calidad de vida? Y la respuesta a todas esas preguntas es retórico esto. Naturaleza, 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 naturaleza. Entonces tenemos que entender quizás lo más fundamental, la naturaleza está primero.
Te presentamos Territoriar, una app que te permitirá aprender sobre nuestra biodiversidad de una manera lúdica, didáctica y completa. Chile es un laboratorio de una invaluable riqueza en biodiversidad presente en sus ecosistemas terrestres y marinos. Descarga la app, disfruta, aprende y educa a distintos cursos y edades a través de realidad aumentada y fichas con información descargable para ser usadas en la sala de clases o desde la casa. Vamos a territoriar.
cambio climático altera el ciclo del agua. Somos testigos del derretimiento de glaciares y de cómo las condiciones hidrológicas afectan la generación eléctrica, los caudales en la cordillera, el almacenamiento en los embalses y con ello la disponibilidad de agua potable y el suministro para riego. El agua es parte de un todo y no podemos entenderla desvinculada del territorio.
La planificación y gestión hídrica se deben realizar a nivel de cuenca, considerando la interacción entre ecosistemas terrestres y acuáticos. Entendiendo nuestra diversidad geográfica, necesitamos evaluar distintas alternativas de infraestructura, verde, gris o una combinación de ellas, que se haga cargo tanto de la cantidad como de la calidad del agua.
El desierto se expande. Debido a la disminución de las precipitaciones y al incremento de la temperatura, se proyecta que el aumento de la aridez afecte al 10% de la superficie continental chilena, es decir, 71.400 kilómetros cuadrados. Análisis de periodos comparados estiman disminuciones respecto a la media histórica de precipitaciones, como también una reducción en los caudales mínimos diarios y el incremento en los caudales máximos. Esto último porque, entre otros factores, las altas temperaturas favorecen el derretimiento del hielo y de la nieve.
Chile es un país altamente vulnerable al cambio climático y esto tiene importantes consecuencias. Enfrentamos una mega sequía, han sido más de 10 años con bajas precipitaciones que junto a otros factores nos ponen en una condición de evidente escasez hídrica o desbalance entre la cantidad de agua que demandamos versus la que disponemos.
Ya podemos ver cómo la provisión y regulación de flujos de agua son alterados por el cambio climático y otros vaivenes en la demanda, con graves consecuencias para el ecosistema y la sociedad, tal y como la conocemos. La Mesa Agua del Comité Científico de Cambio Climático, convocada por el Ministerio de Ciencia, Tecnología, Conocimiento e Innovación y conformada por 97 académicos, revela la relación entre seguridad hídrica y el bienestar humano como un elemento central para enfrentar el cambio climático en Chile y el mundo, entregando herramientas que consideran factores como la normativa, institucionalidad, información, calidad, planificación y gestión del agua. Cuidar el agua es cuidar la vida. Ministerio de Ciencia, Tecnología, Conocimiento e Innovación.
El cambio climático y la evidencia muestra que la temperatura en Sudamérica superó la del siglo XIX en 0,6 grados Celsius. El cambio climático es una de las principales amenazas globales a la biodiversidad. Altera los procesos fisiológicos de las especies y sus interacciones, el comportamiento de los organismos, la estructura y funcionamiento de los ecosistemas y su distribución. En un ciclo que se retroalimenta, afecta la captura del carbono y la cantidad almacenada en el suelo, los ciclos de nutrientes, la productividad, la polinización y la resistencia a los patógenos, transformando los ecosistemas.
A partir de la generación de evidencia empírica buscamos contribuir a mejorar la relación sociedad-ecosistema, para mitigar y poder adaptarnos mejor al cambio climático. Ahora, esto requiere, por un lado, cambiar ciertas prácticas productivas y también prácticas económicas que tienen impactos negativos sobre los ecosistemas y que contribuyen también al cambio climático. Y por otro, reconocer que el ser humano es un componente más de la biodiversidad y depende de él.
El impacto del cambio climático sobre la biodiversidad y la forma en la que nos relacionamos e interactuamos con ella contribuye a que los ecosistemas y las funciones que prestan se degraden, afectando su capacidad de mitigar emisiones y de aumentar el bienestar de las personas.
Las soluciones basadas en la naturaleza son un apoyo importante en las iniciativas de descarbonización de todas las economías en el planeta y en particular de la chilena. Adicionalmente proveen cobeneficios para la adaptación y la biodiversidad y requieren, eso sí, proteger los ecosistemas y restaurar sus capacidades para capturar carbono de la atmósfera.
Cuidar los ecosistemas es imprescindible para evitar el doble impacto en la biodiversidad y el cambio climático. Por ejemplo, cuando el suelo está contaminado, eso se expande a ríos y océanos, promoviendo la proliferación de microalgas nocivas para la salud humana. Asimismo, la pérdida de bosques hace que se deje producir oxígeno y no se pueda secuestrar el CO2 que contribuye al calentamiento global. Impactos como el anterior hacen imprescindible que tomemos conciencia del cuidado de la biodiversidad si queremos hacer frente a los avances y efectos del cambio climático. Atendiendo esta realidad, 105 académicos se comprometieron con el Ministerio de Ciencia, Tecnología, Conocimiento e Innovación, dando vida a la mesa Biodiversidad del Comité Científico de Cambio Climático. Porque potenciar soluciones basadas en la naturaleza promueve el equilibrio entre lo económicamente sustentable y lo medioambientalmente sostenible. Ministerio de Ciencia, Tecnología, Conocimiento e Innovación. Chile es altamente vulnerable al cambio climático. Sus impactos van desde la disminución de recursos hídricos derivada de las fluctuaciones en el nivel de precipitaciones y el derretimiento de nieve y hielo, hasta consecuencias climáticas como la mega sequía que afectan tanto a la población como a la infraestructura y a los sistemas naturales. Al cambio climático se le atribuye la extinción reciente de especies, alteraciones en su distribución geográfica, actividades estacionales, migración de especies, repercusiones negativas en el rendimiento de cultivos, entre otros tantos impactos en diferentes ecosistemas a nivel local y mundial. El concepto de adaptación tiene que ver con prepararnos y resolver las consecuencias de un cambio climático producido, en gran parte, por la acción humana. Es esperable entonces que sea la misma sociedad la que se haga cargo, aumentando la resiliencia y reduciendo las vulnerabilidades.
Para lograr el desarrollo sostenible en Chile, se deben implementar medidas efectivas de adaptación a nivel sectorial, nacional, regional y comunal. Tomando en cuenta la incertidumbre y más allá de la meta a la que aspiramos llegar, la implementación de cualquier medida se debe entender como un proceso en constante evolución que implica resolver permanentemente los impactos que ya existen y prepararnos para los que vendrán en el futuro.
Para avanzar en la adaptación al cambio climático, es necesario hacer frente a desafíos que muchas veces están vinculados con el desarrollo, como son la pobreza, el hambre y la disponibilidad de agua. De las crisis deben emerger las transformaciones como procesos conscientes y guiados que promuevan establecer objetivos comunes, la creación de nuevos modelos de desarrollo y avanzar en justicia social y ambiental. Ello implica capturar y mirar evidencia que nos inspire en el establecimiento de nuevas medidas.
Para responder al cambio climático debemos adaptarnos, y aunque mucho de lo que estamos haciendo hoy es útil, para esa adaptación no es suficiente, por lo que hay que complementarlo con innovaciones y cambios profundos. Debemos realizar procesos y respuestas transformacionales para salir adelante. Por otro lado, aceptar que el cambio climático está lleno de incertidumbres activa el potencial para diseñar procesos transformacionales que involucren a distintos actores sociales, utilizando a su vez información basada en ciencia.
En Chile hemos avanzado en el diseño e implementación de políticas públicas, pero aún existen posibilidades de mejora. Nuestro país debe ajustarse a los impactos del cambio climático de forma transversal, a distintas escalas administrativas y con participación de múltiples actores sociales, donde la ciencia cumple un rol clave al disponibilizar información y evidencia científica al servicio de la generación de políticas públicas y propuestas en materia de adaptación. Es por ello que con la participación de 73 académicos y cumpliendo con el mandato del Ministerio de Ciencia, Tecnología, Conocimiento e Innovación, se construyó la Mesa de Adaptación del Comité Científico de Cambio Climático, generando conocimientos y propuestas concretas de apoyo a la toma de decisión. Porque adaptarse es mucho más anticipación que reacción. Ministerio de Ciencia, Tecnología, Conocimiento e Innovación.
Mitigar es una herramienta fundamental para hacer frente al cambio climático. Es intentar neutralizar la emisión de gases de efecto invernadero, impidiendo que el planeta se caliente en extremo, lo que en concreto se traduce en metas de largo plazo, para evitar el aumento de la temperatura superficial del planeta, más de 1,5 grados Celsius sobre los niveles preindustriales, de acuerdo con lo planteado en el Acuerdo de París. Pese a que Chile produce aproximadamente el 0,3% de las emisiones a nivel global, nuestra incidencia cambia al considerar agrupadamente todos los países que se encuentran en similar posición y que juntos aportamos cerca del 40% del total de gases de efecto invernadero. Somos entonces parte del problema, pero podemos ser mucho más protagonistas de la solución.
Debemos tomar posición respecto del gran potencial de Chile en energías renovables, tanto para abastecer nuestros requerimientos energéticos internos como para exportar. Nuestro potencial de producción podría cubrir en torno al 10% de la energía que se demanda en el mundo. Exportar energía limpia.
Thank everybody because thanks to connect here again for the second panel of today. In this block of our expositions, they will show us some models of monitoring of different threats associated to climate change presented in the south cone of our region. And they are valuable experiences that could be implemented in other countries. We will open the presentation of José Marengo. He's a physicist and meteorologist from the Universidad Nacional Agraria de Perú and also Universidad de Wisconsin in Madison, United States. He did a postmaster at NASA and the University of Florida in the United States. He's professor of the program of Master of the Institute of Research, Spatial Research of the Universidad Estatal Paulista. He's director of the Center of Monitoring and Alerts of Natural Disaster in Sao Paulo, Brazil. Member of the World Academy of Sciences and the Academia Brasilera de Ciencias. He researched on climatology, climatic models, climate change, hydrology, and reducing of the risk disasters. Very much welcome. The floor is yours. I thank this invitation. It has been an honor to participate in this event. And I will show you what has to do with our panel, the experiences of monitoring and climate change, variables associated in Latin America. You have seen in the previous sessions what has to do with the IPCC and the main results. So what we need to see in this moment are the problems of the climate. The extreme climate are even more extreme for the next decades. Chile, for instance, you are there with suffering the crisis of droughts and the process of water, the crisis of water in Sao Paulo, Brazil, that now includes wetland. As they say in Portuguese, it's hitting strongly, and the consequences in Paraguay with the Paraná River. Argentina is suffering a lot because of the impact of this extreme phenomena. So one of the ways of talking about monitoring is collaboration. And the countries of Latin America and the Caribbean, with their meteorological services of all the region, throughout all the region, from Mexico to Chile, we prepared the state of climate in Latin America, which was published now in 2020. And there you can see the figures of global warming in the Caribbean, Mexico, and in South America. In 2020 was one of the 10 years warmer from in America, in South America. And we can see the red dots that show where the temperatures were higher than normal. Basically, in all the region was over the normal. So we can see the consequences also reflect on salt. The main snows in the Andes, Central and South Andes, are diminishing their volumes in terms of masses, what is bringing a lot of problems with the regions and the rivers of the region, because they depend on salt. One of the works that we do in SEMADEN, which is our Center of Natural Sciences of the federal government, is to use an index of draws. It is different, a bit different than the other ones. It's an index based on surface observations as well as of remote sensors that have to do with the state of the vegetation. In the different years, while you get a more red, a reddish index, we have a higher cost in the 2017, 2019, 2020 in Pantanal region, which is that blue region near Bolivia, and also in the south of Brazil. And in 2021, it's in almost all the region in the northeast, in Pantanal and in Paraná. And this index was applied to all South America and the Caribbean, and up to Mexico, as a form of uniforming an index that maybe is more expressive than other ones. In the map of the left, in the left side, you see Chile, in the central part of Argentina, all the Plata River and Pantanal and the northern region with extreme draws, and you have the arrows with SPI, SPI, and you see 12 months with draws in Pantanal that were already detected some years ago. The same in Central America and Northern America with the monsoons, which were quite weak. And in terms of rainfall, we can see in the lower part some areas in green in Central America as consequences of a season which was very intense in hurricane, and in some areas of Amazonia in the northern east of Brazil, but in Pantanal, Chile, Peru, Ecuador, and all that region with negative problems in rainfall. In terms of raising of the sea levels, the data observed by Copernicus observer, as you see in the map at the right, augmentation of the Atlantic basically more than in the Pacific. The idea of this report was to show that there are sectors of collaboration among countries. But the best way to monitor extreme events is not only gathering data, but also interchanging experience and collaboration among countries. Brazil, through IPE, has a platform, Adaptabdacil, that you can see here in the screen, which has index of impact on climate change integrated in one platform. Here we have the strategic sectors, water, food, and energy. And there the region that is applied as a pilot experience is the northeast of Brazil. In that region, we can see the vulnerable maps, where you can see the dry areas and vulnerable areas where this data is showing vulnerability and others no. This will be applied to Brazil with our intention of extending it to other countries of the Plata River. Through CISAR, we are working together in order to study more the draws. And here comes the idea that aside from this meteorological center, to use some previous alert and climatic alerts in order to prevent natural disasters, because we are not very well prepared in Latin America. In Brazil we have, but they are only dedicated to water events, but since we do not have earthquake or tsunamis or whatever, instead Chile is very active in monitoring tsunamis and earthquakes. So these centers that work with alerts would reduce risk, and that reducing of the risk is something that will help governments to manage risk through civil defenses. This is an expensive effort, but that is interesting to be done. Here we have a product that was done through the net, Ibero-American Net of Climate Change. What refers in the right side and the left side. In the right, we have health, and the other side, we have landslide. And without any more detail, the early alert systems, early transference of technology, system of maps for climate change, epidemiological surveillance, and landslides in front of natural disasters in all the ancient capitals with many risks, threats, and a series of initiatives that are done by each country with the scope of reducing the risk and the number of dead people in the case of landslides because of the impacts they have. So what is being monitored is not only data or interchange of data, it's also experiences of survey systems and monitoring systems. That is something that in a way we are able to do it from Mexico to the south of South America, including the Caribbean, of all these experiences and services of water, meteorology, and analysis and research, academic research, of all the sectors that work. So the human capital exists, and what we want is to work together at the national and international level, because knowing this, knowing about the climate in the current days, we will be in a better position in order to face what is coming in the future. And this year, up to the moment, is giving a lot of examples of what will be the climate in the future with the report of IPCC just published, the conference of the part of 26 in Glasgow, the environmental issue is on the heat, and so we have to take advantage of this in order to go forward with the different measures that will avoid that the climate will be a disaster for our sons, daughters, and granddaughters and grandsons in order to adapt to a more difficult and impossible moment. With this, I finished my presentation. Thank you very much to the Scientific Committee for the invitation. Thank you, Doctor. Very interesting, your presentation. The experiences of collaboration. These are challenges that we need to face, and in an international way, and not only with one country. We continue then with our second panelist, Juan José Nieto. He is Magister in Business Administration and Oceanography. His research is the analysis on climatic, with emphasis in the impact of the climate in risk management and climate change. He works in Ecuador in the International Center of the Phenomenon El Niño, CIFEN, on the development of sectorial climate services, and he is the international director of such center. He coordinates the group of regional seasonal climate in South America with Climate El Niño and the net of volunteers for the climate in pilot areas of South America. He has been an instructor in themes related with climate, oceans, and different workshops having different publication and regional projects related to climate, extreme manifestation, and risk associated to their impact. Very much welcome, Mr. Nieto. The floor is for you. Thank you, Soledad. And thank you, the committee, for the invitation that you're doing for CIFEN. And going to the point, I want to comment that observing observing the atmosphere as well as the ocean comes from several decades ago. The images we can see meteorological stations that have centuries of years registering data in Santiago. BMC as one of the eldest of the region, eldest stations of the region, monitoring the atmosphere and the oceans. And we cannot forget this because have to do with the regulation of the climate and has been monitoring from the 60s and the 70s with this ship in the ocean that you can see in the images. Nevertheless, this has evolved due to the apparition of the satellite information. While the satellites in the 80s, in the past century, have been giving us information of what has been happening in the Earth, they have become the eyes of the scientific that have allowed us for the first time observe the planet from a point of view, a global point of view, from a dimension that was not possible previously because we made punctual measurements in the measure that we could do it, but we started with this studying models and in the oceans, for instance, as the discovery on how are the processes that propagate and maintain, like the El Niño or La Niña, events that manifest all the road of the Central Pacific, but affect also other systems and affect the whole planet. Finally, we saw variations in the medium level of the oceans. We saw how these phenomena propagate and a lot of parameters that previously we couldn't visualize. And the enormous volume of data that was generated also allowed us that the numerical models of prevision of the climate started getting better and developing and being used with all the computer's capacity that was developed by those years. And now we are with numerical models that can foresee with time, with a greater or less degree of preciseness in the world. And new models try to foresee the climate, like take a bit distance from the immediate thing of the next days and try to establish models for the next trimester or for the next month and try to better the scientific global development as well as the development of these climatic models. Recently, I think that La Niña or El Niño, as a warming of the seas and the ocean, integrated among all the changes that are provoked in the oceans by the El Niño or La Niña in the atmosphere, with a high degree of certainty, we could now, with 6 months ahead, know the behavior that it will take. And this has been bettering. And it gets better while the systems of observation improve and have capacities that we can process all that data through the computers in the universities, in the centers of observation also. Nevertheless, we cannot forget or leave aside the importance that has the observation in the territories, the observation done by the meteorologist observers, the ones done by the ships in the ocean, the one done through the stations, the meteor stations that exist on land. Because this allows to make the adjustment of these predictions of this model. And aside from the prediction of the climate, of the seasonal climate, we have tried to project, we have tried as a society, the scientific society has tried to project the climate to the future in decades ahead, so to estimate the degree of uncertainty that a projection of such magnitude could have, but to try to see how the climate will change in the next years and decades. So we have a whole chain of development from the observation in the local observation to the observation from the satellites and the incorporation of all that information to climatic models and the integration of techniques in order to foresee the climate and have a global view and a projection, global projection of what could happen in the planet. But we cannot forget or leave aside the local observation, what the people does in the territory. And here I show you these faces that for me are very significant. This is a net of people, volunteer people from different sectors. This is not a professional net, but a volunteer net that work in the river Chinchinaque in Colombia. People that come from the farm, from different agroecological farm or tourism or from minery, that said we are also interested in being part of this and be part of this net of observation of rainfall in this case, but they contribute in a significant way to give us the lack of, to fill the gap of the lack of information in the territories that the models, the satellite models, are not able to measure presently. So maybe in the next decades the satellites will do, but for the moment this is done by the participation of volunteer people, and this is just an example, but there exist nets of observation from private companies and in the farms, companies of water supply that require this information to develop their tasks. And with this information, they can obtain measurements and registers of rainfalls in these places. In some places, even remote places. In order to finish this part, I want to say some reflections. For instance, that observation is a task of everybody, not only of the meteor services, but it's a task that implies all of us. As we saw in these examples, there is a big development of volunteer people and nets. Thanks to a great consciousness that the communities have in order to become part of this. And it is the movement of volunteers for the climate, and the data and the use of climatic model and complex ways of projection due to the date of the satellites are very important, but we do not have to leave aside the observation from the local areas using these nets of volunteers and exploiting the use of social nets that nowadays are a great tool to communicate and put in discussion all these issues like climate change, like reducing the emissions, and so on. And they have a great power of change and a great power of transformation. The data of observation must be shared by all, because it's a problem that is being reduced, fortunately, in the last years in some countries that have open policies that share their data with others, and we should point that all the information is open and shared with everybody for a lot of uses that they could have. We should involve the private sector in these matters, in these systems of monitoring systems, in these nets of monitoring, and in a lot of activities, because the private sector has an important role and must be here considered also. And of course, the universities, the development of technology and new techniques and instruments and tools. The university has a basic role in our countries where the economical resources are limited. The universities and the private companies have an important role. The adaptation to climate change must point towards the sustainable development. That means co-design with the communities, and the communities must participate in these measurements of adaptation so that they are acceptable and sustainable with time. It's a challenge, and Mr. Marengo commented in the previous presentation the work done in order to establish the state of the climate in the region. And it was a big challenge to have all the data, but the data that has the needed quality and the extension for this kind of analysis. The data must be homogeneous and can be, so that they can be used and have quality in order to be used. This is a big challenge in where we all have to work here with the quantity of information that we can get from the territory, and also to try to reduce this difference among the countries in the region related to the research on climate change, not only in terms of climate, but also in social sciences. We need to have an explosion of research in social issues also, and how these affect society, and they are more complex issues than just the climatic. And of course, in order to finish the approximation to the adaptation of climate change, must be finally of a cross section. It must be of multiple sectors working together. There are many issues that I should leave here, but I want to conclude with this issues. Thank you very much. Thank you.
Muchas gracias, Juan José. Muy interesantes las reflexiones y este llamado a que todos seamos observadores del cambio climático, que todos seamos observadores de nuestro medio ambiente y de la naturaleza. Bueno, y ahora entonces tenemos con el cierre de las exposiciones a la doctora Paula Aitala, doctora de la Universidad de Buenos Aires en el área de Ciencias de la Atmósfera, actual directora nacional de Ciencia e Innovación en Productos y Servicios del Servicio Meteorológico Nacional de Argentina. Ella preside el grupo de estudios sobre observaciones y sistemas de infraestructura oceánicos de la Comisión para Observación, Infraestructura y Sistemas de Información, Organización Meteorológica, de la Organización Meteorológica Mundial. Coordina también la mesa de trabajo sobre sistemas de observación y monitoreo del Comité Asesor Científico de la iniciativa Pampa Azul, de la cual escucharemos hoy día. La doctora Itala condujo el desarrollo de varios sistemas de modelización, predicción numérica y asimilación de observaciones para el pronóstico meteorológico y oceánico, entre los cuales se encuentra el actual servicio al público de pronóstico de olas y ondas de tormenta. Integró el grupo directivo del proyecto de demostración de pronóstico de inundaciones costeras, el equipo de expertos en sistemas de pronóstico de olas y riesgos costeros de la Organización Mundial Meteorológica y el comité directivo del Sistema Global de Observación de Océano. Muchas gracias por estar con nosotros, doctora Itala.
Muchas gracias a la organización y al comité por convocarme para presentar en esta ocasión las acciones que se están llevando adelante en el marco de esta iniciativa que se denomina Pampa Azul, hacia un sistema de observación del océano integrado en la forma de red de redes. Para esto, el Ministerio de Ciencia, Tecnología e Innovación estableció en su comité asesor científico una mesa de trabajo.
A working table ad hoc. Pampa Azul is an initiative which is interministerial, involving 7 ministries of the Republic of Argentina, coordinated by the Ministry of Science. And it's articulating the actions that makes initiatives from different areas of the state could find in the observation of the ocean the answers and information needed for a better development. Through technological development oriented to the naval industry, marine industry, agriculture, biotechnology in the oceans, and technology of deep waters, I am going to talk to the National Observatory of Oceanographic Parameters measurements, which are being developed within this initiative. The themes of this Pampa Azul are the preservation of biodiversity and the spatial marine planning, climate change, management of the environmental risk, prospection, geological and geophysical, and others. And through the law 2767 of Argentina, we created a national fund for the maritime spaces. And this made possible the development and the sustainability of the financing of the initiative in terms of observation systems. The Ministry of Science is the authority that applies that and determines this budgeting. For this big effort towards an integrated system that gives the basic information for monitoring and research in the oceans, the approach is for systems of systems where we address from what we have the integration and the valuing of the oceans offshore and inshore. So we work from the collection of data up until the application of them with the updated technology based on science, and very aware of creating capabilities of human resources that are needed in the initiative and in the cross-cutting areas such as the technological development. We have a different plan in scaling to account for the different capacities that we have in the country in order to do this work on a uniform manner. The general objectives of the networks gathers the objectives of other networks. And the general objective is contributing to the global and sustained observation on the oceans that give evidence and information which are necessary to develop public policies and plans towards a sustainable development. And in the national plans, we have some scientific objectives as well. For example, the development of observations in a wide range of latitudes from the northern part of Argentina up to Antarctica, and systems of meteorological variations and atmospheric dust and coastal marine systems and stresses related to climate change and human activities, and also some networks oriented to monitoring indicators of the objectives of the Sustainable Development Goals, oriented towards some of the specific goals so that they could be available for those who make decisions, and contributing as well to the national and provincial or municipal authorities for the consolidation of their own plans in order to respond this initiative. These networks, some of them are being constructed yet. Other ones that I just mentioned here in the left-hand side, the observation for the Sea of Argentina, we have 9 nodes. Each of them is headed by one or several institutions constituting the networks from Antarctica up to the city of Buenos Aires. In the center, we have a limited network for measuring these indicators of the objective number 13. And here, in a much smaller scale, in a estuary, we have a network which is almost consolidated many years of observation, which concentrates in constant phenomena. So this integration of the networks allows that we are focused on what we have now available in order to have the constitution of a network as a network of networks. We're talking about stations, constant stations with discrete and continuous accounting, with biological nature, hydrological ones in the main cities, autonomous stations as landers, and fixed installations between 20 and 50 meters deep into the ocean. And this network, this INROMA one, is coordinated by the Council of Science of the Argentinian Republic, is integrated by many institutions, private and public. Remarco is another network that is concentrating here, the coast of the Buenos Aires province, and involves universities and institutions on this area. The one called Diado is integrating a global one is concentrated in aerosols for Aeronet from the NASA. So it's monitoring the estuary, both air and sea, and as well as involves fishing, local fishing companies that are given monitoring data. The satellite component of this net of networks is given by the National the national commitment of the space that works together between CONADE and the Brazilian Space Agency, and we want to show is the synergy between this satellite component and the in situ one, which is a fundamental support and contribution for the satellite products as well. So this is going to be called oil. It concentrated two areas, the open one in the open sea and the other one is inshore. The approach on value chain that we give to it is circular in the sense that it is retrofeeding itself based on the evaluation of the impact. We evaluate at the same time the construction of initiatives assuring the quality and traceability of the measurements, contributing to the design and adequation of the objectives of these networks to the objectives of the public policies, both national or international, and we provide technology, the management of this information and the solutions for this management and the interoperability of it in a way that the areas of scientific application can have access easily and find this information available. We do an approach in different phases in a realistic way, allowing the planning simultaneously and parallelly with the first implementation within this first year. We are then including these initiatives in order to have them implemented in the very short term. We're talking about 2022 to have the first results of the implementation. And at the same time, given time to plan the actions that we require initiatives in the short or the medium term, we need a technical preparation, even an institutional one, such as the observation or offshore or in the continental platform, which are much more demanding and they require much better preparation. At the same time, building on the capability of human resources and the commitments of the different organizations for incorporating technical people that can respond to the needs of this network, and at the same time to have a plan for integration, providing solutions for the management of information, which is a big challenge for the initiatives, particularly those based on the scientific process based, which are financed and a very finite or specific period of time to be given. So in the different areas of action that we are developing, both integration and the development of the technical capacity and the development of institutional capabilities that go for sustainability of the system, we find that the development of procedures for recording and having metadata of information that would give us the possibility of having traceability for the use, which is essential for monitoring climate. The procedures for calibration and management of the instrument to give the researchers that are the main ones on the instrument the tools so that they can give it sustainability to this section of the quality of the information given. Strategies such as management and definitions of the different platforms of monitoring and linking the satellites stations, and develop as well data policies, as the previous lecturers said, to be compatible between the different institutions and allowing the accessibility and availability of this data. So that in the last link or segment of the circuit, we could give precisely the information with the necessary relevance and importance that are needed by the plants. Obviously, given priorities, different priorities according to the definition by the scientific system, different areas focused within the region. And also, as these can be installed, can be linked to the subnational actors and players or initiatives in the territory to be adequating the objectives so that we can give an answer. Thank you very much. This is all for now, and I am open to comments and the discussion with the other panel members. Thank you. Muchísimas gracias, doctora Tala. Very interesting the way how you thought of this networking, in fact, not only an isolated system, but also a more complex and complete system to address this complex problem, which is climate change. Now we will have our discussion panel, and we want to address the question is whether it is possible to initiate an agenda of regional observation for the climate change. We are going to have the participation of these three presenters, and we are going to invite we have a little bit of a jamming. Yes, not okay. Thank you. So we are going to have in our panel of conversation moderated by Dr. Laura Farias. She's the coordinator from the Climate Change Committee of Chile. She's an oceanographer and PhD in oceanography, Universidad de Concepción. She works as a professor in CR2 program, Universidad de Chile. She's a representative of Chile for the study on the lower atmosphere and the surface of oceans, SOLAS. She works in the biochemical processes involved in cycles of gases. She has built and reported one of the first marine series of nitrous oxygen and methane in the world. The results are helping to understand the process that explain the variability of flux of nitro through the interface of marine water in the coast. You can give or take your questions through the chat. Now I offer the stage to Laura Farias to moderate this session. Thank you, Soledad, and good afternoon to everybody. First of all, I want to say that I am very happy to be accompanied by this panel in this conference on the, scientific evidence and public policies. I am very honored to be here in this prestigious panel represented by the basin of the Atlantic, Brazil and Argentina, and by the Pacific basin as well, with Ecuador, and me myself there. I am representing Chile, although I have to say that I am from Argentina, from Cordoba. I was born in Cordoba. I believe that I will start as your presentation have been quite revealing. I have just taken some keywords that have really called my attention. When Jose was talking about collaboration and the need of cooperation, Juan Jose, he talked about the models of volunteers, territories, and Paula was talking about the laws, the role of the state, the chain of value, the value chain. So many things that can be united and be met here. So after listening to us, I also want to pose some questions that I have been taking through the social media. I will start by something that I just have thought for the end, but there is a sentence that well, I just try to do Decalogue. The collective value of the set of data is much better than the dispersed value. So in terms of integration in the southern cone of South America, can we go forward through to a regional monitoring system, that is to say, including atmosphere, oceans, biosphere, as a southern cone, or still we have too many gaps in between our countries? I open the stage for you. For whom? Well, I work in Brazil, but I'm Peruvian, so we are mixed in basins. One of the things that we have been working with in there was a project done, financed, in order to integrate the Amazon data on precipitations and rivers in order to see the extremes. It was an ambitious plan that after some years was just on paper. And we started with the SIG planta. We started to work with this, but also, I don't know how far it reached. So one of the things that we saw is, as you said, data are more important where they are all together and not all scattered all around. The experience we had with the elaboration of from the report of OMM was fantastic. So it meant that it is possible to exchange information. Maybe not all data, but some of them could be integrated. We were in the first line, presented by the Secretary General of the Meteorological Office, but maybe there is a lack of political will, because sometimes we do not have access to data. My colleagues in the University of São Paulo, they are suffering because of the extension of the network for the Southern Atlantic. But there is a gap on information here. It is where the cold winds come, etc., and they come into Brazil. So there is a need, yes, of course, of collaboration. Cooperation, as it is being today, is based on friendship more than that, but it's not official. So we need to officialize it, and I don't know how to start this, because this problem, well, I lived in Peru and now in Brazil, but I think it is necessary to think about that. Data are important and useful when they are worked out jointly and not in isolation. Undoubtedly, there is different variability and interconnections where one region can explain the impacts of another, and I believe that this is something that needs to have a scientific evidence concluding that. Any comment from you, Paulo or Juan Jose, on our integration in the Southern Cone? These obstacles or stressors that we can have or gaps? Well, this is not a dream, as you mentioned, but we have to look for the regional mechanisms that can give a framework for an integration that Jose was mentioning. We need to have a common objective. If we are going to have, for example, an alliance based on organizations or institutions, but if there is a regional framework, it would be much more sustainable to have an initiative like this one. For example, it could be an initiative within the World Meteorological Organization with a focus on land, not only in the meteorology that was based on the atmosphere, but an integration of the land system as well. But not all the land system anyway, but just to cover the needs of what we're talking now, integration with an objective of this climate change monitoring, or what we need in adaptation. So along this line, synergy between the scientific sector and the institutions would be a very important goal. The institutions to give sustainability and the scientific area in order to trying to cover everything that we can complement among the different countries. Clearly, alliances among countries and governance, both national and international, give us a framework so that the political wills of the state can come to an alignment and not only coming from the territories of the community. So there are two ways here. Juan Jose, please, your words. It is possible, yes, it is possible, and I definitely agree with what Paola and Jose were mentioning. There are experiences, exchanges that have been made on data for the national products, but it is also true that this is not an institutionalized system. It is just driven by some personal initiatives of scientists, but when they are being constructed, they do work, and there should be a professionalization of this exchange. Maybe it is possible to improve that through the generation of the use or products based on this data, which are shared. I believe that coming to the different countries, what are the data that are being shared? I think that this system could be improved. The paper or the role played by the World Meteorological Organization is key, at least from the point of view of what the variables can be, atmospheric ones, I mean. A long road has already covered or been covered. That is to say, these data should be interoperable trans-frontier, I would say, in terms of the different advances, not from the point of view of the oceans. Oceanographically, I would say that we're still far away of having a real exchange on this kind of a data. But there are some initiatives that have been raised, but these data are not yet flowing to the scientific community. But it is possible. Yes, it is, Laura. Thank you. So this conference has been characterized by hope. So it's very beautiful to listen from you, your optimism.
A question that I want to ask you, so that you can share with the people that are listening to us, is you're experts on climatic services. You have worked a lot on that, but in which way these climatic services are reaching the communities and society itself? Is there a way, a clear way, reachable for our communities? That is my question. Or this is left among the scientists and their ambit for a world, or the academy, let's say, or in a second instance, or an incidence towards public policy, if that should be the case, that we could discuss it. Do we have a society and communities informed, territories empowered that ask for information? Oh, who can answer this?
¿Parece? Con eso.
I can start.
Pues desde mi perspectiva,
From my perspective, we are not reaching with climatic services adequately and in the correct moment and in the measure that correspond to several sectors. We're trying, yes. We have created consciousness, yes. Laura is asking us if we are not reaching or yes. And I think we are not reaching with climatic services to the different sectors that are using them or may use them. And the users are of different natures. They are the ones who are from the farm, from water, from different areas and sectors, and each one has its needs and frequency. How would I need the information? How would I receive it? And the climatic service should point to that, to personalize, to create specific information, specific climatic information for the need of the users, but the users should be the ones that frame that need, because many times we interpret that the farm is requiring certain information in a certain way, but it's not like that. So I think we need to reach them and all the sectors so that they are how they need this information, if it is possible to give them in that way, but to have those conversations if it is needed.
Muchas gracias. Eso después va a ir
Thank you, Professor. After we will go to the public questions regarding original people and popular knowledge, and how does we believe we're giving them some useful information, but the dialogue is not so transversal as it should be. Maybe Paula or Jose have some opinion regarding the territories, the empowerment of them on information.
Que es un centro.
My center, that is quite new center, just 10 years, we do not do prediction of time, but yes, on rainfall, we have some alerts regarding rainfall or flooding or all that information, landslides and so on. We evaluate and we consider them in as climate, population, topography, and all that information is translated and sent to civil defense, and they give some reports or they evacuate some housing, houses. And in Brazil, we basically protect people that way, because our product, yes, it arrives to where the people trust that, because if not, people would die from this kind of accident. But in our center, always there is someone that was taken away from the civil defense, but escaped to get the documents or whatever, and then it came a flood or whatever. These alerts are very important, because even if they are part of climatic alert, enough to say we will have rainfalls in this region. A region may have problems where there is no people, but when there is people, we need to give an alert of the risk of disaster. But the population in some way is already waiting for such a sign, because it was elaborated and translated with our communications team, so that the technicians of the civil defense can talk it with the for the women in the households and so on. But there are places where people don't have such alert system and we are still lacking to improve it. It's an excellent example of how the communities have a protocol of action based on information, which are not just data, but it's processed information to give an alert. Is part of what we are waiting as a scientific evidence information. It is essential for this in all the scales where we are talking, the ones of short run that would save life immediately, as the climatic services of long run, where the evidence could be in the long run statistic and not always so easy to implement. In all cases, for me, it's basic to go further from the providers of service and to put the center in the user or in the sector that will receive it. And this means this is an exercise quite difficult. It's an exercise of leaving that the users push this need, and when we will communicate, to do it in the place, there will not come a rainfall and will have so many millimeters. It could happen this, it could happen that, and it is convenient for you to do so and so. So the impact will be centered and the response in the person. I think that this this capacity would generate a change also in ourselves. Clearly, thank you. I will make some questions that the social nets are giving us. And we will make a closing and a brief reflection, each one of you. I have a question that has been sent, which is the role that the ancestral knowledge of the communities have in these threads, something that Juan Jose has mentioned a bit. Original peoples, native peoples is very sensible theme in the South Cone, is something that unites us, South America, as a continent, our ancestral knowledge and the presence that they have in our current society. Something of which we should be proud. There is a very direct connection with the good practices that will bring us, we hope, to mitigate this climate change, which is to achieve that sustainability of ways of life, ancestral ways of life, will provide the benefit from the scientific advancements to the measure that we will be able to maintain such practices that have to do with the survival of the planet. And many times, the contribution, the local contribution in these systems can be what Jose was mentioning, which is the information rescue. Many times we have in the information of one's own place, one can rescue from many years ago information, and there the contribution of these communities must be of very beneficial for this volunteer work.
Sí, me parece muy interesante esa pregunta.
Yes, I think it's very interesting, this question, because when we talk on adaptation, I have the experience with the communities in Peru and Bolivia. They work with their water and irrigation methods, and I hear them, and they have their ancestral solutions that technically make sense, because after that, those terms appear: adaptation to the ecosystem, adaptation based on community, previously adaptation was to build a big wall so that if the water goes higher, it will not come in, but it's not like that. It is fundamental to have those practices. I remember when I worked on Quito in IPCC chapter on Central and South America, there was a section that worked on that with the knowledge of Mother Earth and all that information, that even if they are based on experience, they have a degree of a truth that going to the field one can corroborate, and many of the ancient people are the best source of information, because they tell you here there was raining before, but now it doesn't rain, and so on. So maybe it's not to quantify, but it's a good information that confirms many times the problems or the information that we have from the scientific level. So Amazonia, for instance, the ecosystem services that we have, we pay them to sustain the forest, because the tourism we know will cut everything down. And that possibility exists, but some sectors from the science does not consider them. Yes, sometimes the natural and physical sciences do not dialogue. That's another problem. That's another problem. So I was surprised when I was in the north of Peru and in Ecuador, how the communities, the Indian communities, know how to adapt to the phenomena of El Niño, how there are buildings, and everything was very surprising. Some comments? Juan José? Sorry. Yes, in fact, there is a knowledge there, very valuable, that has come from generation to generation being transmitted. And it has very important basis, even if we haven't studied them well. We have to rescue, because in many places we are losing it. An example, in Ecuador, in the rainfall at the beginning of each year, some time ago, 40 or 50 years ago, the houses were built in calaphites so that they would be raised over the level of the floor in 2 or 3 meters, and when the rain came, they didn't get wet, and they moved in canoes or went to the place where they put all the animals that also floated and was very much resilient, and they could live together with their climatic reality. But now with the development with cement, with the floods that take all the city, and we are losing that knowledge. We are losing the way people were living, which was very interesting. These communities lived from the knowledge and a permanent interaction with nature and environment. We need to talk. Thank you. I have a question for Jose. The alerts of rainfall, which scale are them? Can you explain how it works? This is done. Brazil is not a country so accidental as Bolivia, Peru, or Ecuador. But disasters kill here. We make a combination of instruments, which are those that are called prismas, because they see a bit the movement of the earth, and all that is in each municipality.
Municipios, distritos, ¿no?
Municipality, and in each district we have areas that are more critical than others. So we have instruments which are being monitoring with the rainfall, for instance, intense ones. We go to the maps of vulnerable areas, which were elaborated and by the Institute of Brazil, and we work with the crisis room. And there we say that for the west part of such district, the alert must be very high. And all that is done according to models, according to instruments with a special net that we put with OMM models and the prediction of rainfall. And then we go to the communication aspect that communicate the alert to a particular website that goes to the civil alert, and that goes to the municipality that has the history of the disaster with documented and with the number of deaths and so on, and gives priority to certain areas. Thank you very much. Very clear your answer. And now we will finish with one question for each panelist. We saw the information and observation from the point of view of the communities, from the point of view of the needs. But now the question is, the states or the agencies of the state, do they value the scientific information, the scientific evidence, and it's translated into public policies, or we have there a gap also at a big distance? Here in Chile, we say, you always want data and information. The academy is the one that demands, but what should we do for the states to value it and to translate it into public policies or effective measurements? And that is the science that we would like to do to better our the way that our people and our countries live. This is the closing question.
Difícil, ¿no? Bueno, ¿cómo llamar la atención?
How can we call the attention of the high levels? For me, could be the question for the scientific what should we do to call the attention? And I think that it's a big advancement of the impact of IPCC. We have been able to create consciousness in the higher levels of the states and the policymakers. And it is so complex what we have to do that it requires something else than political will and agreements. And we, the scientists, should give all the tools that could help them. Because many times, even if we have the information, the implementation needs it also. For the climatic services, we need to give the information for the policymakers to use it. And not maybe to give them so much information, but what kind of information we are giving them. I think we are advancing in this sense. There is a part that goes from up down and another one that goes downwards up, which is creating consciousness from the citizen, from the population, to pressure also to the policymakers to take the actions that needed to be taken. The public policies road is not so easy many times. José? Yes, I think the same. January 2011, there was one of the most big disasters in Rio. Many people died and many people disappeared, and the metro service just said it's an emergency, and then the president said we have to do something. We have a lot of computers here, but Brazilians are dying everywhere, so they created my center. But the truth is a politician does not need to know how the temperatures will rise, but which will be the impact. For instance, Thelma Krug and some others have been here with you. But when they say climate change will affect the agriculture and the soya production in Brazil, which is the main producer of soya production, yes, they will pay attention. But if they say there is a rainfall in Pantanal, nobody will care. But if you say, what will say the international community when they see all these animals burn, but the level of Paraguay river fall, and there is no way to bring the soya to the ports. There's a loss, economic loss. So working in such way, we could say that the climate is theoretical. What we need to have in the policy are the impacts, the lack of lights, of money, popularity, because we are now in a drought situation in Sao Paulo, and the governor will not be very happy when the people will pay. So I think this is a way to speak. Less science, less pure science, and more applied science, and thus oblige us to become activists. If we do not go to the street, the school, the community, nobody will do anything. So we need to do it. Thank you. Juan José.
Exactamente lo que dice José.
The same as Jose was saying, to the politicians, we need to speak in the language that the politicians react. The politicians in general, maybe here there are some of them, but the politicians are worried about the votes, about the image, about the economy. So we have to arrive to them in this language, because if we say from here to 100 years temperature in your city will be 1.5 degrees more, the political cycles are not so long. So we need to face those interests, together with the scientific interest, and combine them with the times of both, reach to agreements and middle points. There are experiences, many, about science generating actions in politics, in public politics. So I think it's that way done, and try to reach a common point where both communities find each other. Okay, there is a shared vision of you three. I think that's the direction. Okay, finally, I think if you want to share a message, in Chile we are just having the opportunity, the experience we lived with COP25. We consolidated and integrated as a scientific community, and we realized that the Chilean ocean, Chile is more ocean than earth probably, was an ocean without too much information and with impacts very little assessed. And we created consciousness, and we have had a will from the state agencies to diminish these gaps. And the Minister of Science, which is a very new minister, that assumed its role and empowered itself of the scientific evidence for the policymakers, help us to analyze, and is working with a climate change observatory. I hear Paula, and with the Pampa Azul program, and it's a dream for us. We would like so much to have such program, and I congratulate you for working on that. How is that? It's a pity that we in the Pacific area, because we share teleconnection, climatic teleconnections, variability modes, but we have so little integration among Ecuador, Peru, and Chile. So with Argentina, we share the Andes and the rivers. Some go to the Atlantic, some to the Pacific. And with Argentina and Chile, Bolivia, we share many of the events, of the climatic events and the oceans, for the dynamic of the knowledge. Which would be the message that you would like to leave in order to close this panel on evidence of monitoring the South? We need to find the common problems and the common worries in order to work together and build over that, over those common points, and think that we are all in the same ship. Talking about the oceans, we are all in the same ship, which is this planet, and it's not that one would be safe and the other one no. We are all in the same ship.
Yo creo que
I would say, as Paula said, we have common themes that are affecting everybody. We have the droughts in Chile, the droughts in Cuenca del Plata. Maybe they have different impacts, but if we want to compare, we need to uniform and to make a study, because if you see the map of IPCC, the area affected by droughts in Chile will continue growing for 40 or 50 years, according to the report, IPCC report. So we have to find themes in common. This is done very much in terms of common proposals. In Sao Paulo, in the state of Sao Paulo, we collaborate with Argentina and with other proposals with Brazil and other countries. So we can do these things at the governmental level. It's beneficiary for both. Sometimes we have more collaboration with the United States and United Kingdom more than with Bolivia or Chile, because it's a pity, because we are neighbors. We need a local collection, more local connection. I perceive that. I perceive that. Maybe I'm wrong. No, it's a common observation. Juan José, please. Events as this one contribute also to that interrelationship, this conversation that we are having. We should take advantage of the language, the northern frontier of Mexico, and those all the same language, and we understand very well among Portuguese and Spanish. So this characteristic, we should use it. We are maybe the same genetics, the same problem. Let's use that and let's complement more. I think we can do it. Only to close, to thank you, all of you, our panelists, for this so good dialogue, so sincere dialogue, without any special interest, but with this on the spirit of pointing towards fortifying the scientific evidence in favor of our communities. So I thank you so much, and I hope that our audience has followed us and has been attentive, and if they have some questions, please send us these questions, because you will give them response. Sure, Soledad, please take the floor. Thank you, Laura, and thank you, the panelists. It has been a very, very interesting reflection, and with a lot of hope, as you said, Laura, to see that the interests are in the people and continue building this scientific evidence for the policymaker. This is the theme of tomorrow. We will concentrate tomorrow in the way we can assess the governments and the legislations that support the work to combat climate change. So this conversation just give us a very good floor to deepen in this issue tomorrow. Thank you so much. Thank you to all the ones that have been connected. This was the third day of the second conference on public policies and scientific evidence in Latin America and the Caribbean. This event has been organized by the Minister of Sciences, Technology, Knowledge and Innovation in Chile, the Scientific Committee of Climate Change in Chile, MEDI Foundation, and the Europe through Euroclimate News. PCC, and the International Network for Governmental Science Advance, INSAS, and also ECLAT. So see you tomorrow early in Chile at 9:15. We will start tomorrow, 9:15, talking about the mechanisms for policy makers for taking decisions. Thank you very much. Good afternoon.